trig, bro. What do you mean?
Look, all I'm saying, all right, is that the trigonometry works sometimes, and sometimes the sky is just very fantastical, and that's why I think it's just double
What?
standard. Where, yeah, come on, you really.
Can you give me an example of celestial navigation where you don't use trig?
I'm not dealing with the celestial navigation right now. I'm talking about just in terms of basically the sky, just being, outside of like trigonometry. Like it's not like you're using it in some cases, right, with the mountain, right? But if you actually like, if you try to actually like locate the star, like the height and whatnot, trig breaks there. I'm just saying, I think it's fantastical, I just think it's a double standard that, when we say refraction, that, oh, it's so, how, what a coincidence, like I'm just saying. But I digress though, because that's irrelevant. I do think though, all right, that we should like, get back to the, the actual topic though. So
Yeah, angles to the stars. Angles to the stars.
Yeah, so your position, just to be clear, is that it's a coincidence that the plane trig measurement to the mountain peak also matches the mountain peak measurement to the star?
no, because you haven't actually confirmed that you've used the star, but you haven't actually measured it with the tool, whatever. I would say once you measure with the tool, we can say for
We,
certain.
we
All right.
measured the time with the
Yeah,
tool. What do you mean?
the time is fine, but let's actually measure it with the, something that actually measures angles, right? You're at the house, whatever, and you measure the angle.
Bro,
Like
you're
because
missing the point. It doesn't
I
matter. That
I
part doesn't
get
matter.
no,
Dude,
because
we could measure 69.9 degrees with a tool. It doesn't matter.
all I'm saying is that there's a lot of assumptions being made, right? And that's not good. You're confirming like, oh, you're confirming your numbers, whatever, based off of like, like a theory that you have. You need to actually confirm it with an actual tool. Like otherwise,
Dude,
you're just making assumptions, and
I don't.
that's not.
You saying that shows me you don't understand what our position is. The optical measurement of what angle you see it at does not matter. That is our position. It doesn't matter. So
Okay.
you saying you need to get a tool and measure what angle you see it at is irrelevant. What matters is what time it blocks the star.
Okay.
Because I can use the time it blocks the star, teleport myself to the mountaintop that's blocking the star, and see what your model predicts the angle to the star from that mountaintop is, and it'll match my plane prediction to the mountaintop every time.
But I'm just saying that I'm calling like BS on this, like I said, because like I pointed out earlier, whatever. Like if you're at the
So you
base
would
of
have
the
to
mountain,
contend that the time is wrong. The only way you could call BS on this is you would have to say when he did this measurement and he took this time lapse footage that his time was wrong.
well, no, I'm
And it
just
just
calling.
coincidentally was wrong in such a way that it aligned with an FE baseline measurement that also matched the angle to the star from the mountain. And it's just a giant coincidence. Or
No,
he's lying and it's a conspiracy.
no,
That's
I'm
your
just
only
saying.
logical, consistent position.
No, listen, all right. Like all I'm saying, right, is that I don't think you should be able to use like trig on this. That's what I'm saying. Like I don't think trig should be even an option, right, for the flat Earth because once again the sky doesn't really behave trigonometrically on a flat Earth. So I think it's just really weird that you're using trig in this scenario. I don't think it should be possible. Is what I'm trying to get at.
What the fuck kind of argument is that, dude? All right, with that said, your concession is noted. And if there's any further questions or comments, if anyone wants to take a crack at it, we're probably going to wrap up here.
I have a quick comment. Alan, I enjoyed you and Dr. Mike's presentation. It was excellent. But I have to say that I also very much enjoyed listening to Piezo and Beasticles because they're also able to present things like in layman's terms. And I enjoy both methods. Yours is more sophisticated, of course, Dr. Heffron and Alan, and I love that. And I think the audience also probably feels the way that I do because we get to see both versions of the presentation, which is great. So thank you so much.
I had a question, if I may. Are we in general agreement, Dr. Heffron, that had the incident angle of the image of the mountain as it arrived at your house been measured, that it would have been about 2 degrees 19 minutes?
So I think the best estimates I've seen are probably 2 degrees 17 minutes uncorrected, and it's the corrections for refraction that are the major point of contention here. Um, and the 2 degrees 17 minutes is a globe Earth prediction. So it's slanted to account for, well, slanted in a funny way. Because I don't even want to go and rocket as 217 because what I've noticed, the reason I developed the celestial theodolite is every time somebody talks about refraction, they're pumping out different numbers: 202, 204, 206, 217, 219, 246. They're just all over the place, and that's why I decided I figured out a two-step process to eliminate for refraction from even being needed to be considered. So step one is let a peak that's at a known location occlude a star. Now you've eliminated any impact of refraction between the peak and the observer because the observer saw that star be occluded, saw the star disappear regardless of what refraction was doing to the angle. And step two of the process is go see where, not an observer, but where the star map says that star actually was relative to the mountain. And that's the 2 degrees 31 arc minutes that agrees with the 2 degrees 31 arc minute at Earth prediction for Pikes Peak. And for Blodgett Peak, I believe it said 1 degree 17 arc minutes versus a 1 degree 16 arc minute prediction. And that's within the range of accuracy I was shooting for. So for all practical purposes, a valid and it's significantly different from the globe Earth prediction. So it's obvious it's matching the flat Earth prediction, but very deviant from the globe Earth predictions, which seem to be all over the place, depending on what they use for refraction.
I'll ask Jesse a question.
Certainly.
Great summary,
Jesse.
Dr. Mike.
Jesse, can you pull out a laser with some maybe sugar water or whatever, get the light bending, and then put an obstruction there and see when it gets occluded?
You mean?
That's a good idea, isn't it?
Yeah, I could do that.
Yeah, that'd be fantastic.
I know.
Because apparently, if the light bends, like it just can't occlude things.
Yeah, I'm not sure I understood that, Dr. Heffron. Is it your claim that the lights from the visitor center, as seen through your telescope, were not affected at all by refraction?
So my actual position is that corrections for refractions are all over the place and appear to be bogus because no two people agree on what that correction is. So therefore, what needs to happen is refraction needs to be eliminated. You can't trust the theodolite measurements because it's affected by refraction. Laser light is refracted. So what I'm saying is you want to watch the true location of the laser light. But what is the true location of the laser light? Well, if you're beaming it through sugar water, you can see what it is. So there's a little bit of uncertainty. But there's not a correction that varies from day to day, from hour to hour, and that always magically agrees with the prediction for a globe Earth, even though the predictions are all different. What this method does is it just completely eliminates refraction by saying we know if the starlight was occluded by the peak, that was at the true angle of starlight, whatever it may have been. So now we go to where does your favorite astronomy tool say the actual location of that star was on the peak that did the occluding, and that actual location eliminates the need for any refraction corrections because it's telling you where astronomers all over the world say that star actually was. And then what we have observed in the very few experiments performed so far, and like many people have said, this is an experiment that can be performed by anybody, anywhere, on any peak, You don't need to send surveyors to my house. You can do this from your house. You can go out in a parking lot. Just find your favorite peak, find your favorite position to observe that peak from. Watch that peak occlude a star. Calculate the elevation of that peak above you divided by the distance that peak is away from you. Find out what angle that corresponds to, and go into your favorite astronomy tool. Find out what the uncorrected elevation of that star was from the peak you saw occlude it, and now you have the true angle of that star. And the question is, does it match the flat Earth prediction for that angle, or does it match the globe Earth prediction for that angle?
So,
Well
if
said.
if by experiment we find that stellarium only gives accurate angles with the atmosphere turned on, then shouldn't we use it with the atmosphere turned on if we want accurate angles?
So in response to that, I have to ask a question. Does everybody agree with your assertion? And I know for a fact astronomers all over the world are turning off refraction correction on stellarium and other astronomy tools because it misaims their telescopes.
I
That's interesting.
highly doubt that, because
Yeah, that's bullshit, by the way.
yeah, because I went out and I by the way, Doctor, just so you know, Shoebill here is a licensed professional surveyor with more years experience than I've been alive. And I'm a hobbyist, but I own a dozen working theodolites or total stations, and I've been practicing using them for about 5 years now. So we're not new to this topic of measuring angles. So is it your claim then that the mountain did appear, if you were to actually measure the angle with a high quality theodolite, it would be around 2 minutes 17 or 2:19, and that missing height is due to the light taking a non-straight path between the mountain peak and the observer?
So I've stated my position several times, and it's not what you're claiming. And my position is that what you measure with a theodolite or a level transit or any other measuring device varies from day to day, from hour to hour, meaning that you have to correct it to even be able to approach anything resembling accuracy. And so the entire reason I came up with the celestial theodolite concept is to completely eliminate all refraction from the equation. So by observing a peak occlude a star, you know the exact time that star was occluded by the peak. Now the only question is, on that, relative to that peak, what was the uncorrected elevation of that star, um, which is based on observations from all over the world. And you can do some research to discover how they get those locations so accurately. But the point is, um, that elevation is the predicted elevation for flat Earth every time, and is very, very different from the globe Earth prediction that varies hour by hour, day by day.
So, for the record, I did a study where I took 36 vertical angle measurements of a mountain 75 miles away and 10,600 feet higher than me, at different times of day, at different times of year, across multiple years, using 11 different theodolites, and my average missing feet was 3,200, and all of my measurements fell within a plus or minus 100 foot deviation from that. So it's not true that it's so random that you can't tell. But the more important thing here is, you're using stellarium in a mode that is not accurate. I have tested stellarium with and without refraction, and it is not accurate if you turn off atmosphere. If you actually measure the angle that you see a star at, stellarium will not match that unless you turn on the atmosphere.
And
All right. So
what are
your
you
position is
measuring it
that
with?
it's a coincidence, right?
Yeah,
I
so this is
Oh.
getting hella circular and repetitive now. Like we've just reached the exact same thing. So if there's no
What
further questions,
Oh, no, the
Alan,
other
I don't. Hey, for the record, I don't think anyone really gives a shit. Sorry, Jesse. If I may, I just want to give a quick summary because I'm retarded and I just listened
oh,
to
you're
this
good, bro.
whole
What's
thing.
up?
And I listened to this whole thing, and what I've heard is that over years and years and years, people have argued about no scientist agrees with flat earthers. Here we have a PhD physicist who has come up with an
He's not a
observation.
PhD physicist.
Okay, a PhD. Sorry. Thanks for the correction there, Roof.
So,
You've
so
done
I'll
great.
actually I'll give you a truer correction than Ruhif.
Okay,
I'm a doctor of computer science.
perfect.
It's
So we have a
It's
doctor.
Dr. Bennett, who is a PhD physicist.
Okay, that's
So
right. So I don't mean to cut you off, but I just wanted to get this out because what I've heard is that you've come up with this doctor here has come up with an observation, and the only thing in response was, "Nope, nuh-uh, he's wrong. That's bullshit." Straw man arguments and everything misrepresentation of the argument, and so I just want to say thank you for putting in your time, Dr. Mike. That's really awesome, and man, it's almost brutal listening to you guys try to cope with what he's presented here. He's given you multiple options
Well,
to
I'm
go out
sorry,
and
and
look.
since you cut me off, I guess it's okay. But this,
I didn't. I asked Alan if I could speak, but that's okay. He's given you the opportunity to go to this experiment on your own, and he's explained why Theodolites and that. But the nuh-uh kind of thing doesn't work anymore, you guys. Like it's really, it's brutal to listen to when you just say nuh-uh, bullshit. That's bullshit. So
Yeah, but
good luck
people
with
have
you
been
on that.
testing Solarium around the world for a long time, and it works everywhere. So
Yeah, we just used it to verify flat Earth elevation angles to physical objects. So that's pretty cool.
Isn't
He
that
doesn't
cherry
understand
picking though? I don't get that.
any of
Isn't
It's
that
that.
a, it's a,
Is it
it's a
cherry picking
coincidence,
if you
Alan.
do it from different locations, dude?
you
So your
didn't include
position now
refraction.
is that it's a
you?
coincidence.
Your
No, but
prediction
you
didn't
only said.
include refraction.
Hold on, but
Yeah.
you only.
So
It's a negligible term. That's why it's not included.
yeah,
I'm,
officially, the only logically consistent position they're even allowed to take at this point is that it's a coincidence. Like that's it. You don't have another logically consistent position as a globularist that you can take.
hold on,
Unlucky.
I'm just. You need guys. You guys need to really clear this up with me, all right? Because I mean, I'm pretty sure it's like like confirmation bias, right? When you choose, right, or whatever cherry picking, right? When you choose, right, the one thing, right, that works out for you guys, but not choose the other thing, right? The location, of the house, measuring the angle, whatnot. If you measure angle from the house and whatnot, it's a different angle, whatever. Like
Yeah.
I just don't get like.
Yeah. So you've been
So
explicitly walked through this multiple times now, and it's not cherry picking. And we have we have two different points for it. So like the fact that you keep reiterating the same
'Cause
thing and then
I
saying
feel like you're
cherry
not
picking
explaining it like
shows that you're
properly.
like either not listening, you don't want to listen, maybe you need some time to think about it and go over it again or something. But the issue here seems to be between the keyboard and the chair. So I think maybe, you should deal with that on your own
Well,
time.
maybe
It's already
explain
been
it to him, like
explicitly shown.
here,
So
I'll take a shot real quick because Dr.
go
Mike
ahead.
laid it out beautifully, right? He took an angle from his house to the peak, right? And in hearing all of the refraction arguments from everybody, like, oh, 204, 206, 219, 246, he wanted to eliminate the refraction between him at his house and the peak. By doing so, he used a star that was occluded by the mountain peak, right? Boom. There's no refraction. That star was occluded by the mountain peak. That's a physical mountain. Now, to confirm that angle, he went to the top of the peak using stellarium. You teleported yourself to that mountain peak from stellarium using uncorrected, no atmospheric refraction elevation angle to the star from the peak. Guess what? It matches the same flat Earth prediction. Now, to confirm it, he used a different peak as well, Blodgett's peak. It works in any peak, and that's why he's saying go to any peak, go to any parking lot, time when a star is being occluded by your favorite peak of your choice, and you can do the exact same thing and confirm the exact same thing. I challenge
Yeah.
everyone to go out and do that.
And the measuring device, because he did use a level transit, but the official position is that part doesn't matter as much. The most important part is your GPS synchronized timing device that gives you the accurate time down to the minutes and seconds of when the occlusion happened. You check. I mean, he has the time down to the second mark of when it was occluded from his time lapse footage. He said, "Oh, it was occluded at 6 hours and 20 something minutes, and so whatever the time was at this second it was occluded. Let me go at this second in Stellarium to the mountaintop to see what the angle to the star is. Oh, look, that angle matches the flat baseline trig angle to the mountaintop that occluded it. That's it. It's super easy. It's a 2-step process. Step 1, watch time the moment that a star is blocked by the mountain. Step 2, teleport to the mountain in Stellarium and see what the true position to the star is, unrefracted.
Or any other astronomy tool. Doesn't matter. Unless you want to actually climb to the top of the mountain that you're looking at. Whatever. But if you want to do that too and use a sextant, sure, but it's not the point.
Right. That angle you get in step 2 is going to match the angle that you get from plane trig. And no, you wouldn't even want to use a sextant, right? Because anything you get with a sextant is going to be affected by optical conditions. The unrefracted angle is said to be the quote-unquote true position of the star as given by the Nautical Almanac. So that's why it's relevant. If you just base it on Nautical Almanac comporting measurements, the angle to the star atop the mountain is this angle. It matches the angle to the mountain from a flat baseline with trig. There's no answer to that other than it is a coincidence or you timed it wrong. Any other answer is not logically consistent in your paradigm.
Okay, so what was the angle for the second peak? Because I don't think I got that. The second, because you guys said you confirmed with the second peak, right? What was the angle?
1 degree, 16 or 17 or 18 arc minutes, I believe.
1 degree. Okay, and how does that what was the other location?
And the star to the peak, Blodgett's peak, was also 1 degree, 16, 17 or 18 arc minutes. I can't remember off the top of my head. It's one of those.
I mean, so was there also was there a real life observation for that? Because remember for the one peak, it was at the person's house, right? They saw the star being blocked by the mountain, and then you guys went to Stellarium to kind of confirm that, right? So was there the equivalent of that, where someone was at a physical location, the star was occluded at 1 degree, whatever arc minutes, and then you guys went to Stellarium?
The star was occluded at a time, bro. Listen, it's a time. The star is occluded at a certain time. Let's pretend I don't have a theodolite. All I have is a telescope, and it doesn't have a crosshair, and it doesn't have a leveling mechanism. All I can do is point it at the mountain and follow the star and wait for it to disappear. And I have a very, very accurate stopwatch, okay, or a watch. And I time the exact moment that the star disappears. I use that same moment to go to Stellarium, put that time into Stellarium, and look at that time from the mountain peak at the star and see what its true position is. And the true position angle, from the mountain is going to match the angle to the mountain from my location using plane trigonometry.
Okay, I get that. I was just trying to.
That's a spooky coincidence, right?
Okay, I was just trying to clarify because I was trying to get some clarification.
But can I get your point? Like your opinion on that's a spooky coincidence, right? How do you account for that? How can that line up for multiple locations? How does that match?
I mean, I didn't know.
It's just a spooky coincidence.
When I went into this, hold on.
We should have everyone do this.
Come on, let me.
Go ahead. We're talking at the same time. There's a delay. Okay. Go ahead.
Yeah. So I mean, when I was as much as I could of the live stream, I saw a little bit of it, whatever. And I was hearing you guys talk about it afterwards, right? I didn't care about the second peak, so that's my apologies, whatever. I didn't, it was never really brought up. It was just mainly the one, Pikes Peak or whatever. Yeah, I mean, I don't know. I guess if you have the data or something, send it my way, whatever. I would like to see that, the other peaks and whatnot, because like I said, I only heard of the one peak, so yeah, it would be nice if I could see the other peaks.
So you could do this yourself,
yeah,
if you just have a telescope, basically. Or, I mean, technically, you could probably use a camera. If you got a Samsung that's got a good enough zoom and you got a tripod, you could probably just do it with a camera with a tripod because you don't need an accurate enough angle. You just need an accurate enough time. So, and since the timing on your phone is already GPS synchronized, then as long as you have a timestamp on your video and you go and see what time in the video the occlusion happens, you could use that as your time reference marker to go to the mountain peak and stellarium.
The thing is, Dr. Mike predicted the flat Earth angle before he even got the Theodolite to confirm it. Just using plain trig, right? You got the elevation of the mountain, you got the distance between you and the mountain, and then you can get your angle, right? The predicted flat Earth angle was 2 degrees 31 arc minutes.
Okay,
So he got a Theodolite to confirm it from his house to the mountain. And he was like, "Huh, this is crazy. How can I confirm it even more? How do I get rid of refraction? Let's use a star." And the time when it gets occluded by a mountain, a physical object, to remove the refraction argument between him and between the house and the peak of the mountain. Then you use stellarium or any other astronomy tool, put yourself on top of that mountain, and see if it matches that angle. And guess what?
Yeah,
It does.
I'm not really fighting that right now. I literally just asked for the
I just
data on
wanted you
the other.
to hear the logical steps he made. Like, first he made a flat Earth prediction, okay, and then confirmed it with a Theodolite, then confirmed it with the celestial Theodolite observation. And this is, am I right, Dr. Mike? That's what happened. Just want to make sure I don't want to straw man you.
You stated it very well, and I concur wholeheartedly with your advice. This is so simple. Everybody can try it for themselves. Don't take anybody's word for it. Do it yourself.
Yeah, I'm gonna do it. You know what? I'm gonna go Saber. My buddy Saber is in here. He's been listening. We're gonna go do that, bro. We're gonna come up with our own observations. I'm down.
Make
got
sure you
loaned
get
out.
Yeah, actually, I was just thinking traveling to Missouri in a couple of months, and they have a nice area where all the stars are visible, and I would love to do this. So,
Nice.
yeah,
Go
I'm
ahead,
excited to
brother.
do that. Yeah.
Anyone
Yeah.
can do this, and I think that's where we
Also,
should leave it.
thank you. Excellent presentation. Really cool stuff. Fascinating stuff. Thank you.
Can I ask Dr. Mike what his error bars are on his time? Is it down to 1 second? What is it?
On my timing, it was probably plus or minus 1 second.
What does that equate to in terms of error and angle?
On air, that's approximately 15 arc seconds.
Per second?
And right, 15 arc seconds per second off, approximately, because it depends on your viewing angle a little bit. But you get Stellarium will actually tell you that. You can step through it and see how much error is introduced for every second you step. And then, as I noted in my original presentation, there's several other uncertainties. Like I did this with a time lapse camera with a 1 second exposure, 1 second time lapse. So that could introduce another second of error. So now we're talking about 30 arc seconds or half an arc a minute of error. And then in the case of Pikes Peak, there was an additional potential error because the height of the building was, I believe, I put this in the presentation, but I believe that was another 15 arc seconds. So there's a 15 arc second error here and there, which could add up to 3 seconds, 6 seconds. I'm not exactly sure, but even if it was not that accurate, so that you were off by, and I estimated overall for Pikes Peak, my overall accuracy was plus or minus 2 arc minutes. My Blodgett Peak accuracy was plus or minus 1 arc minute. Even if that's off by a factor of 2 or more, there's a clear differentiation between that angle and the angle predicted by the globe Earth model. So it's a no contest. You can clearly see that, yes, it matches one or the other.
So what's the difference in measurement, or what's the difference in prediction from flat versus globe versus the error measurement?
For Pikes Peak, it was 27 arc minutes.
Oh, damn.
And
27 arc minutes. Okay.
it's a huge difference. And I don't have Blodgett readily available, but I think that if my memory is any good, which it may not be at my age, I think that was 18 or 19 arc minutes difference. So it was way, way beyond the margin of error, the difference in what the two measurements should have been.
Okay, cool.
But it is true, it's demonstrably true that in the case of your house in Pikes Peak, you would have gotten the same results on a globe, and I can prove it.
Interesting that you can get the same results for both models in the real world. I thought that they were different.
Well, the distance just happens to be right for both to work. Not all distances would be, but that one was.
So
Why?
a cosmic coincidence, right?
No.
So you're
just-
saying both Blodgett Peak at 36 kilometers away and Pikes Peak at 51 kilometers away are both coincidentally in the right place to make globe Earth and flat Earth be identical.
Well, you didn't measure a star clipping behind Burgett Peak. You only did it on one place. You only got 1 point using your celestial foot theodolite.
That's an incorrect comment. I measured many, many stars on Blodgett Peak and on Pikes Peak. I only took one ever theodolite measurement, and that's the one that made me realize you can't use this theodolite measurement because they require too many corrections, and the corrections are all over the place. That's why I devised this much more precise method of figuring out what is the true angle.
Have you released?
You said before, sorry, Jesse, just one sec. You said before that you've stated your position many, many times. We've stated also many times making corrections to any measured angle. Okay?
Right.
We're
And,
not
and my
correcting any
contention
angles.
is the fact that you have to make so many corrections to come up with the right number for your model, and I don't need to make any corrections at all for mine. That's a glaring discrepancy in our procedures.
Okay, so I incorporate refraction into mine. Do you accept that refraction alters the position of things?
Yeah, he literally
No,
just said.
no, not at all.
Dude, oh my gosh.
Yes, no. Yes, no.
Refraction alters the apparent position of things.
All right. So where is that in your prediction for a flat Earth?
So even
If you weren't listening at all, were you, bro?
Yeah, you're not, and that's my whole point with Rue is intentionally misunderstanding.
Oh,
I
don't
think.
start that shit. You already went through the entire PDF calling me Satan.
No, an
have a
Australian
conversation
reptile.
like an adult.
Get it correct, Ruhi.
Yeah, but it's meant to be Satan, right? Just have a conversation like an adult. Can we do that?
Well, you're the one who can actually steelman our position.
Yeah, you can't steelman it.
Explain the concept of a celestial theodolite, please.
Yeah, you put the observer somewhere where he wasn't. Is that correct or not correct?
Arguing against your misinterpretation straw man, or are you trying to argue what we're arguing?
Yeah,
Do
sarcasm straw man.
Do you put the observer where he was or where he wasn't? Is that correct or incorrect?
So you can't steelman us.
Ruhiv, maybe you should steelman, and then everybody can give a rating from 0 to 10 how good your steelman
that's fine.
is.
But I'm saying I'm not steelmanning it. Is it correct that you put the observer somewhere where he's not?
This is your steelman? You're asking this question?
Well, I get pulled up as soon as I get one line in, so I want to check where I'm at.
Could you
Dude,
start
we
from the
asked you like
beginning?
20 minutes ago to do it, bro.
Yeah.
How about you start from the beginning? I think I gave a good steelman. Do you remember what I was saying?
So
You've
put the observer
given like
somewhere where he's
3
not.
good ones. You've given like 3 good ones. Or 3
Is
or 4.
that a straw man of your position that you put the position?
How about you just give our position of why our significant, what the measurements, why it's significant, like
give
why
a fair
it's a problem
steelman, and then give a criticism. But give a fair steelman first. It's very
not a criticism.
simple.
I'm explaining your position. Do you put the observer somewhere where he's not? Is that a straw man or is that correct?
Okay, so you're not starting from the beginning. You're not starting from the beginning. That's not a good steelman. No. Start from the
It's the
beginning.
only chance of having this be productive, basically. That's the bottom line, you know? So if you can steel man, at least make sure on the same page, then you can give your point, and then it can be the most fruitful, because then everybody can see both sides. All of our time can be most well spent for everybody listening in terms of the sides being able to be fully put forth.
Right. Am I straw manning it to say that?
You're just going to like ask the same question over and over again, aren't you?
And I don't mean sides in a back and forth way. I'm just saying in general, the perspectives, the points being,
Why don't you ask that question after you steel man?
Right.
And then ask the
I'm
question.
steel manning it, but as soon as I say what you're actually doing, not a straw man, is it a straw man to say you're putting the observer somewhere where it's not?
Yeah, it's over. It's over.
Okay.
Can I ask you a
Yeah,
question,
Yeah,
Rudy?
this
sure.
is intellectually dishonest.
Oh, shut the
You
fuck
have
up,
to be
Liliana, you
able.
stupid bitch.
You have to be able
Whoa.
to
Hey.
actually steal
Hey,
man.
all right. I mean, yeah, that's a
wrap.
You should probably wrap it up, man.
I think that's
She
good,
can I
Gio.
ask a question?
I don't think these guys. I don't think they can steel man it. Who said that? Someone wants to ask a question.
Can I ask a question? Sorry.
Yeah, if we want to have, I mean, we're moving on for sure from that. What, unless anyone says otherwise, but yeah, I mean, Rue, that's not cool at all, bro. Anyways, what do you guys want
Can
to
I
do?
please ask a question?
Yeah, one or two, something else that's on point before whatever you.
Well,
Yeah, go ahead.
yeah, Swallow, right? Go.
Yeah,
That's a great
Swallow.
name.
Yeah.
Go ahead.
Yeah, I was kind of curious about the fact that star has a negative 15 declination, which puts it about 104 to 105 degrees below Polaris. How was that predicted on flat Earth?
What?
The star that this observation was pointing towards is a negative about 15 or 14 degree declination, which basically means it's 105 odd degrees below Polaris. So I was wondering how this is predicted on flat Earth.
Okay, so this is a totally non-relevant question to what was just presented.
Yeah, I'm not on the topic that Rui was on, but,
right.
but I mean, you guys are pointing towards the star, which actually is below.
Same explanation that was given the last time you brought it up. So the negative coordinates are just where the star would be when it's out of your field of vision. You guys consider it under a ball. We consider it just out of your field of vision. So it's just represented by a negative coordinate system. And then when it's merged on two hemispheres, like the mapping of that, that's what it comes out to look like. So it's totally fine. That's why this observation is so important, because it shows that the actual interpretation of the coordinate system that's being used is with respect to a flat baseline. That's why all these measurements give a mutually exclusive angle for the flat Earth, and then when you turn on refraction, suddenly you get the globular prediction that's not manifested in the occultation time. So hopefully that answers your question. If not, that is the answer to the question. So I don't know what else to tell you from there.
Yeah, and the thing is, this can be replicated by anyone, anywhere, right? So it's sort of like, at this point, it's like, let the data flow in. Like, anybody can do it in any scenario, and at least they can present what they get. And then, of course, wherever they do replicate it, once they present that, somebody else can then replicate that to see, to double check and et cetera. So like anyone who presents anything, even that can be replicated, and then that can be, either submitted or presented as well. Because for like folks on the side of saying that the Earth has curvature, coming from, in terms of this, if this were to be done more and more times, and it's always getting with the planar geometry, what position do they have? Yeah.
Well,
It's
you
a cosmic
people use
coincidence from
stellarium all the time, and their observations match stellarium.
You're talking about visual optical measurements though, and we're talking about physical ones. And so to rectify to rectify the differential between an optical measurement and a physical measurement, we can use this method, right? And so when we use the mountain as a reference marker to physically block a star, all of a sudden it matches a flat baseline.
And all of a sudden you transformed your location to 50 kilometers away as well.
Right, and you made an optical observation anyway.
Yep.
Sure, but our
still
point was that the optical
theodolite. Hold on, dude. You're still using a celestial theodolite. That's an optical instrument.
Sure,
So let's
but
look Theodolite. It's something.
we have to use the optical time that it was occluded, and when
Optical
we do
time?
that, when we optically visually saw it be occluded.
The timing which it was occluded, man. Like, let's not get
Yeah.
into like irrelevancy, right? You guys, can you follow along now that we have the proper? You guys know what we're talking about now. So when it gets optically occluded at a specific time, right? So that's what we're saying. So now that we're all on the same page,
Right,
continue,
because they would
please,
argue that it's already physically occluded. It's just not optically occluded, right? Because it's behind the mountain the whole time. That's what they would have to say. But
Now we need to
anyways,
find. Now we need to find a perfectly lined up spot.
Hold on. Wait, I don't think he was finished. Go ahead, bro.
yeah. So, anyways, once you do that and you then go to the reason that you use Stellarium, by the way, right, is Stellarium, it has the useful ability because it's programmed in to the nautical almanac to tell you what the nautical almanac says the true position of a star is. We don't care about what visual angles it says it would happen or any of that. All we care about is true position. Remember, because this isn't supposed to be an apparent measurement. It's supposed to be a physical one. Because physical objects block physical objects. So when we
You're
do
doing
that,
this optically, of course.
yeah, when we do that, it just happens to line up and match a plain trig prediction.
Yeah.
Now
the globe,
and that's not being contested, right? Because I mean, we have everyone saying they're not contesting the time the star was occluded. So then the only logically consistent position you have left, if the time wasn't wrong, is that it is a coincidence. That's the only logically consistent position left in your paradigm. So if y'all would just admit that it's a coincidence and say, this is just a coincidence, nothing to see here, folks, move on, we could actually at least somewhat academically and intellectually respect you for that. Maybe not entirely, but more so than what position you're taking right now. Because right now you don't actually have a position other than, nuh-uh, you guys are wrong, Stellarium's right.
Yeah,
which doesn't actually have any meaning because we're not
measurements against Stellarium all the time.
Yeah, but we're not contesting what Stellarium says about what we see.
Yeah, you are.
You are actually.
No, we're saying that where the star physically is where the mountain physically is, which is where the flat Earth baseline prediction using plain trig says it is.
Yeah, and just to reiterate, just for anyone who wants to do this, can even test it beforehand, right? Take any favorite mountain peak that you know about, do a distance from that mountain peak, right? Calculate what the flat Earth prediction would be, which is just plain trig, right?
And refraction.
And then go into Stellarium, put yourself on top of that peak, and there you go. Voila. It'll match the same prediction.
Voila,
because you don't have to worry about refraction when you've got two different objects and an occlusion between them and a time.
I'm gonna do
no
this.
There being two objects doesn't make refraction disappear.
Oh, well, I guess refraction is cosmically conspiring to match a flat baseline. Then that's also a coincidence. Cool.
Well, it's sort of
you
like
just added
the
a second
problem is
variable.
the light.
I think of it
The
as like
problem
you're
is the
splitting it
light
in
from
half.
the distant object is able to be refracted anyway, regardless of whether or not there's something in between you and it.
No, I do hear you. I kind of think of it as like splitting it in half in a way because you have that like it's almost like the halfway point at the peak of the mountain. So you have sort of like a more reference than when you know in terms of elevation and distances. So
Yeah, I mean you can even use a
he
steeper
actually-
angle though. Let's
but
all
it's the
use a
same-
steeper. We could all use a steeper angle though, right? A way
Right.
steeper
Same-
angle.
Same
Right,
optical
Shane.
quarter, right? Yeah, that's what I'm gonna say. So it's the refraction can't apply one way and then not the other or whatever.
Well, even if they try to do that and make it apply differently, like on the other side of the mountain, and say that mountain just arbitrarily is the change point, right? Even if they tried to do that, they don't realize they're making it worse for themselves because if you add refraction in as a second source of variability, then now you have to say there are two coincidences that are converging to give a plane trig baseline match.
Right.
See, in our
Right.
version,
Yep.
there's only one thing that's converging as a coincidence to give a plane trig baseline match. But now, since they say we also have to take into account refraction, now you're saying refraction's also happening and it's still matching what we predict. So it's actually worse for you if you say refraction, just so you know.
No, we're just acknowledging that light from a distant object is not suddenly not subject to refraction just because another object is between you and it.
That's
Look,
fine.
people
So
making
two coincidences.
people making that argument don't understand our position, right? Because they're trying to equate the angle between the positions of the house and the mountain. It's saying that one is accounted for refraction, one isn't. Not understanding that our argument has nothing to do with the difference of angle projected or not projected from those two positions. The concept of the celestial theodolite is using the mountain as a crosshair, and then the astronomy tool, in this case, Solarium, as like the timestamp on the bullseye, right? That's how the concept of the celestial theodolite is employed. I even heard somebody says your celestial theodolite is wrong without even understanding. It's a concept we made up for this presentation based on Dr. Mike's observations and measurements, right? To use a theodolite in this way to gauge a star behind a mountain peak is, in fact, the celestial theodolite concept, just so everyone's clear, right? And that's our position. So trying to refute the distances between the 2 points or refraction on or off has no effect on the argument. If you guys manage to defeat that argument, it doesn't affect our position at all, just so you know.
Well, it does. It changes the prediction you're making because you've made the wrong globe prediction.
No, our prediction does not need
We
refraction.
don't even need a globe prediction. That's up to you guys. Good luck.
Well, wait. You're saying you don't need to check whether or not the globe prediction actually matches this observation?
Well, you can try. Go ahead. I challenge you guys
So
to do it.
when the globe prediction does match, what do we do now?
What do we do now? I don't know. We
No,
live
no,
in
no, no,
reality.
no. The way that you get a prediction of like a reciprocal nature to refute it is that you have a different star occlude at a different time and have that time equate to the angle that would match the globe prediction, right? You can't just use refraction or just say, hey, that's our prediction now. You have to use the same method, right, to affect the same different angle. So you'd have to use a star to occlude a mountain at a different time, which would then equate to a different angle, right, for a different position of that star. That's what you'd have to do. You can't
That
just
would not
say
match
refraction.
plane trig. It would have to not match plane trig when you then went to the position of the mountaintop and viewed the not viewed
Exactly.
but calculated the true position of the star.
So we have one observation that doesn't disprove the globe.
No, dude, you just didn't listen to the presentation and don't know what you're talking about. I don't know how to tell you in any different way.
What was
Well,
the
the
Okay,
name?
the observation being discussed by the mountain occluding the star doesn't disprove the globe, so we need another observation.
What was
That's
the
just
name?
your
I think I
opinion,
know.
man.
If I could jump in, I think I know of a way to help Doofus understand this. Using the laser and the sugar water example. Oh, let's let the laser be the star, and it's in a known position. And if it were a flat Earth, we can calculate the position where that laser is and where it's aimed. But when it enters the sugar water, it bends. It refracts. Now, what happens if you stick an occlusion inside the refracted laser beam? It will disappear from the other side of that occlusion.
What?
But
No. A laser beam goes around an occlusion.
No,
is it?
he's saying to occlude the laser beam, dude. What are you talking about?
Right,
I'm
you
saying
can
you
put
stick a
something
piece
that's
of.
on a straight line path between the laser and the observer, and you'd still see the laser if the path the laser took is bent.
You're not listening. You're not listening. I'm talking about the refracted laser beam in the sugar water. Stick a tongue depressor or something in there. Will that or will that not block the laser beam where it hits the tongue depressor?
If you block the bent path, then you won't see it. But we're
That's the
talking
point,
about
right?
there being a
Right,
straight
that's
line
the point.
between the
Is
star
saying.
and the observer,
That's
which you say is
exactly what.
blocked by the mountain,
If
and
you would
therefore
please be
a
quiet.
bent path would go around that mountain.
Go ahead, Dr. Mike.
The tongue depressor in this case is the mountain, and we're sticking it in the refracted beam. It occludes that beam, so the observer sees that beam disappear. That does not reflect the true position of where that beam originated from the laser pointer. The laser pointer is the star. And if you think about that very thoroughly, you'll realize that's why a mountain peak occlude a refracted beam and still indicate to you where that beam originated if you can identify the true location of that laser.
The medium refracting the star is behind the mountain as well. What are you talking about?
Yeah. It seems like you told me I wasn't listening, but you didn't listen to what I said. So if you put the tongue depressor on a straight line path between the laser and the observer, the tongue depressor is between the laser and the observer. If that laser takes a path that is bent, the observer will still see the laser, even though the tongue depressor is in between the laser and the observer.
No, what he's saying is to occlude, to actually block the laser path after it's been refracted. It doesn't matter.
Okay, so the observation that we're looking at, where a star is being occluded by a mountain, you haven't confirmed that the mountain is between the observer and the star.
He's confirmed it by the fact that it blocks
yeah,
it.
when I got occluded at a specific time, that's the confirmation of it, Brody.
Yep.
Yeah, the fact that
you
it blocks
did that
the star.
observation optically and ignored optics in the process.
What? Buddy, it's based off of a time, and we're optically viewing it. What you said is incoherent AF, brother.
Okay, so the light from the star
celestial
could be
point.
refracted more than the light from the mountain, couldn't it?
A death blow this is, I guess, man.
Sure,
Awesome.
sure. If it's in your paradigm, yeah. But then it would just be a coincidence that it lined up with trig.
So then we have an observation that doesn't refute the globe or a flat Earth.
Wait. Can you concede that it's just a coincidence? Can you concede that it's just a coincidence that it matches trig?
It doesn't really, because what you're suggesting is that stellarium can be wrong for the observer's position.
Dude, we just broke down the math. It matches trig.
It doesn't, because you're assuming 60 nautical miles per degree doesn't exist in reality.
Wait. Is 231 the trig prediction to the mountain? Yes.
231 isn't the prediction to the star from the observer's location.
Hold on. Wait. I didn't ask you that. Is 231 the prediction to the mountain with trig?
231 is the prediction to the mountain, but not to the star.
Okay. Is 231 the prediction to the star from the mountain?
It's not the prediction of where the star will be for the observer.
Hold on, from the mountain. If you're on the mountaintop, is 231 the prediction to the star?
You have to acknowledge that the star is going to be lower for the observer because the observer is not on the mountain.
On the mountain, is 231 the prediction to the star?
It doesn't matter because the observer's not on the mountain.
So it's a yes, right?
We're talking about a person being we're taking it to a human, for somebody on the peak of the mountain.
He knows.
What is
He
the
knows.
angle to the star? You agree that's 231 from the top of the mountain?
It's irrelevant because the observer's not on the mountain. There's nobody standing around and making this observation. There's no reason to point to the star from the mountain peak.
Yeah, you're only saying it's irrelevant because the two numbers match, and that's just a big coincidence in your paradigm. You don't have an explanation for it. GG, bro.
But it's not just. Hold on. The guy that has the camera has to know where the star is from his position, doesn't he?
231, right? From the mountain?
Not from where he is.
From the mountain, though, right?
Just admit
not from where the person with the camera is.
Can you just be intellectually honest for once in your life?
Has to see the star in a different place, or else 60 nautical miles per degree doesn't exist.
Hey,
listen, we don't need a distance. We can backwards derive the distance based off of the timing and the angle. That's not a factor in it. Continue on, please.
I'm not talking about any damn distance. I'm saying the star is going to be in a different place for the person with the camera. The camera is not going to see the star in the same place as the mountain.
So I just need you to be honest enough to say 231 is the prediction from the mountain.
Right, but it's irrelevant because the person with the camera is not standing on the mountain.
So when you say yes, but it's irrelevant, what you're saying is yes, that's 231, and yes, the trig angle to the mountain is 231, and those two numbers match, but it's irrelevant and it's a coincidence. Right?
Why is it? Why I don't
the
understand
reason why it's
relevant.
irrelevant is because the observer with the camera isn't going to see the star in the same place. Because again, 60 nautical miles per degree is a thing we observe in reality.
So is it just a coincidence that the two numbers match each other using plane trig?
I mean, it can be. The reason why that angle is 231 from the top of the mountain has nothing to do with the person with the camera. That number is completely irrelevant to the person with the camera.
It's either a big coincidence or it's statistically significant and materially important to our paradigm. So you take one of those two options. The choice is yours.
It can't be
means that they're
significantly. It
horizontal,
cannot be statistically significant because the person with the camera won't see the star at 2:31.
Okay,
It's
so
not
then
possible.
it's just a coincidence, then, right?
I'm glad that you talked over me finishing my answer. You fuck.
Wow, everyone's getting all emotional. I
Okay,
think we should wrap
let's
this
talk
up,
over every.
Gio. What do you think?
Damn. Language,
this
gentlemen,
That's
please.
right.
Okay.
That's the
Can I
answer we
say
need.
Galarian.
something at
Okay.
least?
So,
Yeah, I
okay.
was just
So
saying one
Galarian.
thing, just that the horizontals are parallel. Is all I was going to say. Is what
But
that
isn't
shows.
it?
Go ahead.
But they're talking about the observer. Isn't the observer observing the mountaintop?
Right.
Correct? The observer is not observing the star. We're observing the mountaintop. And then the star is going behind it. So that is why angle to the star from the mountaintop is valid, correct? As a layman listening to this, as someone who wants to go duplicate this in her backyard, I am understanding that as the observer, I want my angle to the mountaintop, and then I'm going to watch that mountaintop occlude a star. So then the angle to the star from that mountaintop should match my trig angle to the top of that mountain. That seems pretty simple and straightforward. Is that correct? Am I understanding this correctly?
No.
Yeah.
Yes.
You have to.
No, you 100% nailed it.
Yeah, for sure.
No, but if you put
Absolutely am. Correct. No, I'm correct here. I'm not wrong. And we can go duplicate this. That is correct.
Let's do it.
And also, Kat, right? You can't forget that, their whole contention, right? Because they acknowledge 231 plane trig. They acknowledge 231 for mountaintop. Their whole contention is that, but that's not where you should see the star from your location. It should be different. But the problem is even if it quote unquote should be different, right? Where you should see the star or whatever being at whatever angle you see it, that doesn't change the fact it's being blocked by a mountain. And so you can get a separate conversation going where you say, okay, well, what's the cause as these objects get close to the horizon that, the angles change from what they should be and yada, yada, yada. Like, that's actually a separate topic. It's a separate conversation, what the cause of this optical compression, optical effect, optical refraction might be. But the fact that we have a physical occlusion, and anytime you time it, it matches a plane trig prediction of tracing a line, you have no answer for that other than to say it's just a coincidence. And that is not satisfactory.
I've got an answer. It just so happens that, though you've heard of 1 degree per 69 miles, it just so happens that at 31.5 miles, that would raise the apparent angle of the star by 0.456 degrees. So at that particular distance and height difference, it just happens in this case to also match a globe. And so that's the problem here, is it does match both.
So they just need to repeat this at a different elevation with the different metrics.
Wait a second. 0.456 degrees. Isn't that 27 arc minutes?
Could be.
Okay, so 204 plus 27 is 231. I'm pretty sure he had a slide about this in his presentation using the arc sine formula of the distance over the radius to get that same amount of correction. Now, that specifically, that 27 arc minutes is different from the refraction correction prediction, which is about 16 arc minutes, 15 to 16 arc minutes, right? Yep. So there's a differential there of about 11 arc minutes. 27 would be the FE prediction, and 15 would be the glow prediction. So
wait. To answer Jesse's point, so Jesse, you're saying it matches, right? But did you account for refraction? Because you said you have to. So you would get a different angle, wouldn't you? If you added refraction in.
Because now if you add refraction, then why is the occlusion time based on a flat baseline? Because I thought they were supposed to line up using refraction and not the raw measurements.
Yep.
He turned off refraction in Stellarium.
Yeah, but you guys just said you have to account for refraction, so why don't you?
Yeah, But he measured it in real life, the time it occluded, and according to you, every optical view that we ever take is refraction. Correct? Is accounting for refraction because refraction's happening. So there's no way when we take this timing in real life where refraction is supposedly happening, there's no way it should match the refraction off plane trig versus the round refraction prediction because the two are different. One is a 27 arc minute shift and the other one's a 15 arc minute shift.
But do you see my point? How if Earth is curved, we would get the same results.
No, we wouldn't. One would be 15 and one would be 27.
Are you sure?
I literally just explained it. So anyways.
Yeah, anyway, celestial sphere.
Welcome
Celestial
to the dawning of a truth gold rush, because as more and more data, and this can be done all over the world essentially, and see what all of the net results are, and the fact that the foundational data without adding any refraction is having that planar, that shows a foundation. Because like we were saying before, like even to try to do a globe type thing, if you want to try to say like from the star to the mountain peak and then from the mountain peak to the observer, you want to say there's like two different forms of refraction happening there. So even though it is on a globe, they would say, oh, it has to be like perfectly refracting on both of those sides in order to be a perfect coincidence to cherry, that it would be a cherry pick, like, and that would be what they would have to say is happening. But if it's, and even if they want to say that about one of them, okay, I guess even if I to half give it to them, but then when it's done a second, more and more time everywhere, then to try to claim that there's a perfect refraction happening all over the world, everywhere, in two different entire corridors to perfectly make it all match the planar geometry is at that point just like beyond a preponderance of evidence that would just get stronger and stronger over time.
Yep.
Yeah, Gio, there's also, this hasn't been brought up in the discussion yet today, I don't think, but there's also an even further extra point that's also has to be a coincidence in their paradigm. So Dr. Mike actually took the angle to the mountain on the globe, right? And it was like uncorrected, was like 217. Okay. Instead of applying the terrestrial correction formula to it, he applied the celestial correction formula because they're actually different, right? They use a different
way more refraction.
Right. And when he applied the celestial refraction formula to the mountain, the angle to the mountain matched plane trig as well.
Yep.
No, I just checked my
Crazy,
math,
right?
And I was correct.
So hold on, Gio, what do you think about that? Have you heard of that before, dude? Maybe he might have stepped away, but that's just any. Oh, you there, Gio?
Well, yeah, no, I am here, but I did get distracted for the last second. My bad, dude. I'm sorry. If you wouldn't mind repeating it, or I'll go back and listen real quick. Yeah, sorry.
Yeah,
Go ahead.
so I said there was another coincidence that wasn't actually brought up here yet today, from what I can tell. Dr. Mike also did another thing where he took the globe prediction for the angle uncorrected to the mountain, which was like 217, and he applied the celestial, not the terrestrial, but the celestial refraction correction formula to it, which is a bigger
raised the angle.
And it brought the mountain from 217 to 231, which is the plane trig prediction.
Yep.
So when he applied applied celestial refraction to the terrestrial object, it became a plane trig measurement. Also,
wow, yeah, there it is.
Is that right, Dr. Mike?
Yeah,
that's right. But I would like to point out that when I presented that, I said that's just one data point. It's possible one data point is just a coincidence, and that's what began me on the path of realizing that refraction is the problem. It's everybody and his brother is making these refraction corrections, and what I began observing is the refraction corrections make the difference between flat Earth and globe Earth. And so that's when I set about a way to completely eliminate refraction from the equation.
Nice.
That's how they determined what the quote unquote correct amount of refraction is Yeah, because they didn't know what refraction was. All they did was assume that it's happening, and that must be what's causing these differentials we're seeing. Well, how much of a differential are we seeing? Well, we know it's a globe, so if we just calculate what it should be versus what we're seeing, there's your refraction, here's your standard formula. That's what they did. So they actually worked backwards to get to refraction.
It's pretty crazy,
extrapolating
actually.
from the celestial sphere, exactly, to a presumed globular surface. Phew, yeah.
Right,
Well
which
said.
is our argument the whole time, which is definitely our position.
So it's just a reification to begin with.
And Dr. Mike, when did you become a flat earther?
I think it was right about January 27th when I first saw that the star matched the flat Earth angle. That was my first step. Probably the second step is when I measured Blodgett Peak, and the same thing happened. It's like
It's
a
too
3 sigma
coincidental,
level.
right?
Yeah, to a 3 sigma level of confidence, I'm a flat earther.
Woo! It's 99.7%, baby.
The way I heard it was you gave us awesome tools from still a globular position, but then when you used the tools that you gave us, you convinced yourself accidentally. That's just how I heard it.
So that's a good interpretation because, as you know, when I joined your group, I was convinced yours was the globe, but I felt like you were all kindred spirits. You realized we've been lied to about a lot of things, and you were digging deep to find the truth, and you were using good methods. And so my original presentation was about the luminiferous ether because I'd written a book on that. And anybody who cares about that can find that on GitHub under Dr. Mike Heffron. It gives the presentations, it gives software, but as I was listening to the debates you were having with our Globe Earth friends, I realized they were using a lot of dirty tricks and that you guys needed better tools like the null hypothesis.
Absolutely.
Yeah, and so in the process of showing you how to use the null hypothesis to determine whether the Earth is a globe or flat, that's when I accidentally discovered it's flat, and you made a convert of me.
I love it. I love that story. I'm gonna keep telling it my way though.
But that's okay. I won't.
We
I
are
won't.
so happy to have you.
refute your way. It's a good interpretation.
I love to hear your more detailed.
So
wait,
again, everyone should do this. Everyone should repeat this. Go find a mountain peak. Calculate your plane trig, right? The distance between you and the mountain peak. Get the elevation and the distance between you and that mountain. Boom, you got your angle. Put yourself on top of that mountain using Stellarium or whatever astronomical tool you want to use. See if the angle matches. And then if you really want to get, deep, get yourself a Theodolite and do that angle without any refraction correction. See if it matches.
He
also,
claimed that the elevation
bonus-
angle he measured to the star from his house doesn't match Stellarium.
Yeah, because
Also-
it's taking into globe curvature of the ground, bro. That's the point of him cutting that out.
Because Stellarium uses the celestial sphere, 1 degree every 69 miles.
It's the graticule, bro. Were you here for that earlier?
What
No,
was
it's
the
really simple. I mean, I don't know why you're saying that Stellarium is wrong.
I thought he measured the mountain, though.
No one is saying that Stellarium's wrong. When you say
Yes,
that,
you
you're not
would
giving
be.
context.
You would be
No.
saying that the elevation angle measured from his house to the mountain is not 2 degrees and 19 minutes. That is 2 degrees and 30 minutes.
Well, actually, if you listened this entire time, we said the angle measured to the mountain optically doesn't matter. All that matters is the time.
Why not?
Because, dude, I've went through it like 6 times, if not more.
Yeah.
You should probably just go
All right, then
replay.
take a back seat. If you don't want to go over it again, let me
He
know.
has no argument. He hasn't heard anything. He
Yeah, the argument is, listen close. Ready? The elevation angle of the star from his house is going to be 2 degrees and 19 minutes on Stellarium. Are you saying that
Why?
Stellarium is wrong?
Hold on,
Yes
wait.
or
Why?
no?
Do you know why it's that?
Because he's also claiming that the elevation angle of the mountain from his house is 2 degrees and 30 minutes.
Hold on,
And
I want you to answer why, though.
And the star got occluded by the mountain.
I want you to answer
So
why
is
it's 2
Stellarium
degrees,
wrong,
19 minutes.
or is Dr. Mike wrong?
Hold on, bro. Why is it 2
You
degrees
don't even
19
know what I'm
minutes?
trying to tell you. You're not paying attention. Do you want me to
Yeah,
repeat it for
this.
you?
Hold on a second.
I
dude.
know.
He's trying to
Yeah.
respond. Hold on. Just let him respond. At least. Beasticles. Yes.
Okay. I just want to. You know why it's 2 degrees 19 arc minutes from Solarium from his house to the mountain peak?
It's actually the height of the star is actually 2 degrees
Not the star.
5 minutes, and then they invoke refraction because of how
Not the
close
star.
to the horizon.
The mountain peak. The mountain peak. Do you
The
know
mountain
why?
peak would have to be the same height that Stellarium predicts for the star at that time.
No, not the star. The mountain peak from his house to the mountain. So from the mountain peak to his house, 2 degrees 19 arc
Right.
minutes on Stellarium. Do you know why?
Can you answer my question first?
What's your question?
If he's taking an elevation angle from his house to the star, and Stellarium is accurate for literally everyone else who ever uses it, then his measurement would have shown 2 degrees and 19 minutes. Are you
Okay.
saying Stellarium is wrong?
Do you know why it's off by 27 arc minutes? We went over that. Were you paying attention?
No. His claim would be that it's off by 12 arc minutes.
Yeah, but is that optically or physically?
So now optical measurements don't work. So what are we even talking about?
No, the whole point is that when you talk about refraction, that's an optical effect purely. And we're talking about a physical obstruction and a way to measure that.
Right, trig, not a measurement.
But blocking a star, taking the time, comparing trig to the different location and seeing that they match. So the only option you have left is that's a coincidence.
I don't understand. Like, did he actually use an optical instrument to measure the elevation angle of the mountain or not?
Did you just hear what I said?
Listen to
That's
my
just
question,
a coincidence.
since now you're not answering it.
Yes.
Ready?
Yeah, you're just
You're saying
trolling,
yes.
bro.
He did. Yes,
So
he
then
did.
the
From
elevation
his
angle
house.
that he measured would have had
Yes.
to
Honestly
have
trying.
been 2 degrees and 19 minutes.
But hold on. Number one,
if you're
that's not
saying
what
it
he
was 2
measured.
degrees and 30 minutes, then Stellarium is wrong.
Hold on a second. You are skipping completely over our point, and you're arguing against a man made of straw
I don't
right
think
now.
you have a point. I think you're a liar.
Oh, that's nice.
Hey, well, hold on one second, dog. I'm
Yeah,
just going to go
that's-
ahead and mute you there. Bezio, go ahead and correct this man. And then Globe, Globe Pop Tart, go ahead and get your final thought off. And then we're just going to move on from that or whatever. So go ahead, Pizio.
Yeah, so the whole point is that he did take a physical measurement, right, just for good measure, but it doesn't actually matter what his measurement of the angle was because, as he said, throughout different times of day, etc., that angle can vary. There's variability in that angle. But what's important is that he got an accurate time for when the mountain occluded the star. And based on that time, if viewing the star from the mountain at that time, it matched the same angle as the plane trig angle to the mountain from his house. So that one could then, using a flat baseline, trace a truly straight line from the star to the mountain to his house using that same time. In your paradigm, you have to either completely ignore that and just not address it at all and keep asking questions about, well, what angle did his theodolite measure? Or you just have to say, that's just a coincidence and it's irrelevant. That is what happened, but who cares? It doesn't actually mean anything. It's just a coincidence. That's the only logically consistent position that you can take.
Let's see what he says. You're free now.
Honestly, yeah, this is what I have to say. Are you ready? I'm looking forward to you transforming a celestial sphere to a celestial plane. I can't wait to see what you guys do.
What?
Yeah, so a addressal of
Nice.
the
Yeah,
point.
your concession's noted. Another one.
I have a question.
Yeah, thanks.
Nah. Or go ahead, Jesse. What is it?
What was the name of the star that was timed dipping behind the other mountain?
Ooh, good question.
Ugh,
If
can't
Mike's
remember
not
now.
there, if Mike's not here, I'll look it up
Mike's
from
still
the
here.
PDF. I'm pretty sure I can find
I'm
it.
still here, and I don't think I mentioned them, but it was a bunch of stars. So let me see if I can find the list here. Okay, oops, wrong one. So on Blodgett Peak, it was HD 205605, HD1 Aquarii, LP Aquarii, HD 216718,
Well,
HD 216953, HD 217877, and 96 Aquarii.
and what was the times that those clipped the mountain?
These were all on February 1st. That was the last good viewing day I had. And the times in Mountain Standard Time were 1824.44, 1912.56, 1930.02, 1943.27, 1946.02, 1952.51, and 200710.
Thank you.
I didn't know you did that many stars, Dr. Mike. That's awesome.
And actually, that's only one sheet. I've been recording them on various sheets, and that was the one I could lay my hands on first. And then for the presentation, what I did is I just gave you the average and the variance.
Gotcha.
Write that down. Write that down.
Well, I'll have to just go back, and I couldn't write it down that fast, but I'll go back and get the recording and then write it down, and I'll check it out on Stellarium. But since the only peak that we've been given information in advance for is Pike's Peak, it is true that on a globe of a 3959 radius, the elevation angle to a star would be lifted 0.4562 degrees if you got 31.5 miles closer to it. That is a fact. And the Stellarium predicted angle without refraction at your house, it was 2 degrees and 5.5 minutes. And if you add that 5.5 minutes to the 0.45621 whatever degrees of being closer, it is 33 minutes, 2 degrees and 33 minutes. So it actually would work out that particular case would work out exactly like that on a globe as well.
Actually, Jesse, the math you did is the math for using the differential of the chord to the line, and that correction would actually match anywhere on Earth. The problem is that that 0.456 degrees is 27 arc minutes, which is our whole point. That's different than what your paradigm claims would happen on a globe, because your paradigm on a globe claims it would go from 205 to 221, which is about a 16 arc minute correction. And for us, it goes from 205 to plus 27 arc minutes. So 16 versus 27, there's an 11 arc minute difference there, which is well above his margin of error for the timing differential.
But my point is it not true that on a sphere of 3969 radius, that approaching a star 31.5 miles closer would raise it 0.45652 degrees? Is that true? Just geometrically, if you had a sphere, any sphere, 3959, and you moved 31.5 miles along the surface towards the star, it would raise that much. Is that right?
That would be the angle you'd see it at from the mountain compared to where his point of view was. We're not contending that point, but the problem is we are seeing it blocked by the mountain where he was at the angle that it should be seen from the mountain.
But
so, like, you're talking about something different right now. Like what you're saying isn't actually solving any problems.
But it shows that this particular data point works perfectly on a globe also, because if you have a sphere of a known radius, you can calculate the angle change, the apparent angle change to an object of insanely great distance by knowing how far along that surface you move. And if you take a 3959 radius sphere and you move 31.5 miles along that surface towards a point at virtually infinite distance, that point will geometrically appear to rise by 0.45 to it will.
Yeah, we know. That's part of it. That was part of his presentation. He explained that in the presentation. That's why he did the arc sine of distance over radius calculation. But the point is that wouldn't cause it to be physically occluded by the mountain at the same angle predicted by plane trig to the mountain. It should be different by about, I don't know, 12 arc seconds or 12 arc minutes, and it wasn't. So that 12 arc minute differential should be manifested through something that doesn't match plane trig. It should be a different occlusion time, or at the very least, rather, right? At the very least, even if it did coincidentally happen to be the same occlusion time, the angle from his house shouldn't match the angle to the star from the mountain when it was occluded.
Well, the problem is you're assuming a flat Earth to prove a flat Earth. Your argument only works if all plumbs are parallel. But if the plumb on the mountain is not parallel to the plumb at the point that the timing was taken, then your measurements are off.
We're not assuming it to prove it. We're saying what does it predict? Does it match? Like, you have to have a prediction in order to have anything meaningful in the first place, brother.
Yeah, and this is actually argued in the form of a null hypothesis. So we're actually assuming that the Earth isn't flat for this, or you could like flip it either way. But anyway, yeah, this is just based off of the raw calculations to it. So that's the distinction here. We're not assuming anything, right? So this is just where
I want to ask a question real quick.
You're presuming a flat Earth when your elevation angle to the Pikes Peak is 2 degrees and 30 minutes.
That's what we predict, and we see if it works, right? So that's how you do science.
It doesn't. Stellarium says it doesn't.
Oh, well, the mountain, including the star, said it did, though.
He doesn't understand.
Weird.
You're not helping anyone, dude. Stop
50, you got a question?
So
bro?
weird how that
really
mountain blocked that star, bro. It's so weird how that mountain blocked that star.
Can we let 50 ask his question, Globy?
Yeah, Pop-Tart, let me ask you a question real quick. So, am I correct whenever I'm stating that Dr. Mike said that the elevation angle was changing throughout the day to the star? Is that right? He said that?
No.
No,
well, he said it would. Mountain. Yeah, to the peak of the mountain. Yeah, sorry.
Okay. Okay, so if it's changing constantly, couldn't you just pick a time where it matches?
No, there's only one time when the mountain blocks the star.
Right. That's the point of using the star.
Not just about measuring the mountain, bro. It's about measuring the mountain and star lined up with one another at one specific second.
Okay, so is he planning on repeating this with multiple stars? Or
he just got done talking about this. He's measured it with two different mountains and a whole bunch of stars.
I thought it was two.
Two mountains.
Two mountains and a whole bunch of
two
stars.
locations.
Okay, I'm sorry, I missed that. Okay, all right.
And then anyone else can repeat this with their own mountain of their choosing and their own star of their choosing that gets occluded by with their mountain of their choosing. That's the beauty of it. I'm going to go repeat it.
Yep, and then people can then repeat what you do. So if you repeat it, then someone can repeat what you do as well to validate and cross-validate. Yep.
That's where we should end this, honestly.
Yeah, you good with closing it up here, Alan?
Yeah, I was going to say we're about to wrap up. So, if anyone has any final thoughts and hasn't spoken yet or said anything like new or whatever, go ahead and come through now, because if not, I'm going to wrap up in like 2 minutes.
The only concern I have, I'll say, is that he's picking whatever's matching up, because there's so many stars and there's so many different locations. He's picking ones. I think to further this, you would need us to pick a star and pick a mountain, and then see if that would match. See if he's not cherry picking.
He did it from his house, so it's not that he's like somehow some wizard knows a special place on Earth he can go make it climb up.
No, but there's just tons of stars.
Yo, Mike, can you go over how anyone can do this for any location and backwards derive the necessary information real quick?
And I'll be happy to do that. And it's not about picking stars; it's about observing a peak and seeing which stars that peak occludes. and record the time like I did for each star that peak occludes. And then once you have the date and time and get it to the nearest second at least of the occlusions, go look those up in your favorite astronomy tool. And all the astronomy tool, you're on that mountain peak you just saw occlude star, and ask it what's the elevation of that uncorrected elevation of that star. And just record all those uncorrected elevations you find based on your own timing, and then compare that to what a flat Earth prediction is for what the elevation angle should be versus a globe Earth prediction of what the elevation of that star should be.
Very well. Thank you, Dr. Mike.
Thank you, good sir.
You got dogs to go rescue.
And make sure to download this stream and get this doctor some bodyguards, huh?
I think you'd be all right, man.
I've got about 20 bodyguards at the moment.
Yeah, and he's probably strapped, so be careful there. I'm not saying one way or the other.
All right, cool. I'm going to go ahead and close this out. I'll be back in a minute, boys.
Nice, Dr. Mike.
Word.
He said locked and loaded.
Oh, actually, before I close out, while everyone's here, let me just go ahead and promo tomorrow night. So tomorrow night, I'll be giving a Prezi on reference frames and the physical meaning of mathematics, kind of going over the history of classical physics and how a reference frame is defined, and then how that transitioned into relativity theory after they took some certain measurements in 1887 that we may or may all not be familiar with around here. So we'll get to that tomorrow at 10 p.m. So if you guys are interested in that, that'll be tomorrow.
And to everyone who participated in the conversations shadily tonight, your unwillingness to acknowledge the coincidence is duly noted.
It wasn't a complete loss. Them constantly not being able to steel man the argument and bring it back around. I'm going to tell you what, I feel like I understand this exponentially more than I did before I walked in here tonight.
Right, dude. Someone should explain what a celestial theodolite is to us before they give us their idea for corrections. That should be the new requirement. Explain to me what you think it is, because that's the whole argument. If you're going to give nonsense refraction corrections for the two differing positions and a complete misunderstanding of the argument, like, don't bother. Try to address the argument.
I just think it's so cute how they refuse to acknowledge the cosmic coincidence at play in order to make the observations match our predictions.
I like how you framed their position as the only possible acquiescence to a cosmic coincidence. I do think that's pretty funny.
I mean, they could also say the timing was inaccurate, but that they didn't do that. So that's the
It
only
has
other
to
one.
always work out randomly, just like this, right?
Yeah,
That's the argument.
at all distances for all stars.
Also, thank you, Gio, for allowing this event to happen. Appreciate you.
Yeah, thank you, Gio.
Yeah.
Dude, and
Sure, guys. Cheers.
Round of applause for Dr. Mike joining the community 1 week, giving us a brand new proof better than Eric Dubé in this next week or whatever. Welcome to the community.
What?
You remember how Eric Dubé had 200 proofs or whatever, and Mark Sargent had clues or whatever? I mean, he just joined, became a flat earther, and gave us a whole new proof. Nobody thought about using a theodolite like this.
Yeah, we're just a telescope or a cell phone and a timer.
Literally constructed a conceptual celestial theodolite, used it to prove and convince himself the Earth was flat. Crazy. I love it.
Yeah, did it? The only hard part about this, I feel like, is figuring out which star a star. I see a star in the sky. Which star is that? How do I match that to the nautical almanac very easily? I might have to get out a star chart and figure it out, or is there an app I can use on my phone to scan the sky and tell me?
There's definitely a phone app.
Yeah, and if you look at Globebusters 13.6, I tell you the easy way to figure out what the stars are. And I really love your idea of just attaching a telephoto lens to your cell phone. that you get accurate timing and you can positively identify when the stars disappear.
Yeah, because all the phones are already automatically synced to GPS time. So I mean, like, you ain't got any worries there. Literally, and it literally timestamps when the video is taken. So you're like, oh, the video is taken at 11:05, and at 27 seconds the star was occluded. Okay, we got 11:05:27.
Yeah, this makes me think of it's almost like building a ruler, building a ruler from the ground to the mountain peak. I sort of
Exactly.
yeah, it's like making the first chip on a ruler, but that's very meaningful in terms of being able to have that as like an anchor point.
Yeah,
it's like building a ruler out of the earth in a way, in its relation to the sky, or it's building like the first notch on a ruler in a sense. There might even be a way to do multiple if there was like.
and I also wonder if like we were to use bigger mountains and slightly shorter distances to get higher elevation angles, if we would not see the discrepancy between our optical measurements and the plane trig diminish. Like, I'm wondering even if just the optical discrepancy as far as the angle measurements is actually being increased due to the compression, like the hyperbolic compression effects as the angles get really close to the horizon. Because 2 degrees above the horizon is really close.
Yeah, well, that's what's interesting when you're talking about the celestial refraction. That's where it gets very interesting. Yeah, about how that all actually plays into what is actually occurring with the sky and the ground and the actual geometries.
And what I discovered as I was looking into it is the lower to the ground the peak is, the more difference there is between flat Earth and globe Earth predictions, because their correction factors go way high the closer they get to the ground. So you're going to get the most deviation the lower the peak, if you can measure it accurately. So I recommend go as low as you can and as far away as you can to reduce the angle, where that'll give you the biggest discrepancy between a flat Earth prediction and a globe Earth prediction.
Oh, I get what you're saying. I was actually going to do the opposite and make the angle more steeped.
Yeah, and one other concern I had about the steep angle, if you're looking up at that mountain peak, too steep, rock outcrops and other obstacles may affect your reading, whereas when you're looking at it from a long distance, those things tend to be invisible.
Got you. Yeah, I got Lone Mountain right out here in Vegas. I think that's what I'm going to use.
Yeah. Yeah, it's man. Not only does it match the plane baseline, but also just as the added bonus point, like you could celestial refract the mountain and get it to match the plane baseline too. It's like it's like a double coincidence, man. Oh.
Double
and
rainbow.
then if they want
to, double rainbow every day, on point.
So in order to do this myself, I just need to find a mountain in my area, get Stellarium, and find out where from my location a star will be occluded by the top of the mountain. Correct? Is that right?
No. From the mountain's location, if you were standing on top of the mountain at the peak's elevation.
No, he's right though. You get a mountain peak, and then
he said the Stellarium.
No, using Stellarium to know when the star would be occluded by the mountain to get the time.
Yeah, like I want to go out and try this, so I need to find. Right, that's what I would use. I would use like Stellarium, find a mountain.
Give you the time, right.
Yeah, give me the time, right?
Mm-hmm.
I thought no. He needs to physically measure the time, and then use Stellarium to figure out that time that he physically measured it occluded, what the raw angle to the star from the mountain would be, and that angle that it should be from the mountain should match the angle to the mountain using a plane trig baseline if it's flat, which is what Dr. Mike measured.
I guess I'm not getting your time distinction here.
Okay. Let me try to start from the top and just make it the 2-step thing, the 2 to 3 step thing. Step 1: go outside, pick a mountain, pick a star, watch the star as the mountain blocks it at the exact time that the mountain blocks the star, write it down.
Okay.
Step 2, take that time you just wrote down, go in Stellarium to that mountain peak's location, place the observer on top of the mountain, and look at the star at that time and see what angle it tells you it's at. Physical angle, like not the refracted angle, but unrefracted. Its true location.
Why
that
am I
down.
placing myself on the mountaintop instead of where I'm at?
You're going to in just a second. So you're placing yourself on the mountaintop because you want to be able to attempt to trace a straight line from the star to the mountain to you. Because if it's flat, there should be a straight line you could trace. If it's curved, then it would be two different lines that intersect at a point, making like an arrowhead tip shape.
But Piezo, he does need the time from his actual observer location to see like when it actually does get occluded.
Yeah, that's by going outside and looking at it.
Yeah, and then go check the elevation angle on Stellarium. Yeah, you can check there. Yeah, to see what. Because Stellarium's not going to have the exact landscape perfect, really. Like
that's what I'm thinking. That's what I'm thinking.
So at step 2, what you're going to get in step 2 is the angle, physical angle, uncorrected, true position of the star from the mountaintop at that time. Once you get that angle from the mountain, then you can just get a piece of paper out and say, okay, my GPS distance to the mountain is this. Using plain trig, what's the angle to the mountain? And you'll find that it matches the angle you wrote down in step 2 from the top of the mountain, meaning that it's one continuous line from you to the star.
Interesting.
Yeah, which would then mean that like the two horizontals from both positions are parallel, meaning they're not, level isn't curved essentially, meaning they're then parallel. Everything matches up because that angle has the same baseline. It's just at a slightly different altitude. But the star is obviously so far above that little bit of change in altitude is not going to change it in an extremely dramatic way, in terms of that part of it. So,
I suspect that if this is done accurately, because like you said, you got to watch out for rocky outcrops and stuff. But my suspicion is that if this was done accurately for angles that are like, above 30 degrees, from like 30 to 45 degrees or whatever, that there would be much less of a discrepancy between the plane trick prediction and the optical measurement, and that the deviation is most pronounced when the stuff is really low to the horizon, like Dr. Mike said, because in our spherical grid of vision, it's linear up until about 30 degrees or a little under that, and then below that it starts to compress and become like a parabolic or hyperbolic or logarithmic or whichever one it is. I forget. I have to look at the chart, and that's why you get this deviation from a linear scaling when you optically measure it. But using the mountain is what takes all that away and just makes it a physical obstruction that we can time and figure it out that way. So that's why this is a useful test.
So it doesn't Stellarium is just a tool. I guess I'm not really understanding why I would use Stellarium if it has like the curvature of the globe built in. Like, wouldn't that fuck up?
It's just the timing of the star, bro.
To just get the timing of what the prediction is for the globe?
No.
I can actually jump in and explain
I just explained it, bro. Like I just explained it.
Go ahead, Dr. Mike.
You just explained it, but I'll do it in slightly different words. Even though Stellarium does have the curvature of the globe built into it, that only applies when you're looking down on the Earth at somewhere else that is assuming it's a globe. When you position it to the spot where the starlight was occluded, you're now looking at the uncorrected true location of that star as made as accurate as possible by observatories all over the world. And you don't care where that star appears to be from the mountain top that occluded it. What you care about is where that star actually is relative to the mountain that occluded it. And that's what will be a straight line from the star the mountaintop, the observer.
Why wouldn't I take like Jesse was talking about? If you move like a certain distance, the star's height moves up and down. Why wouldn't I like adjust for that? Like I could adjust for that fairly easily, like using Stellarium. Why wouldn't I do that? Why wouldn't I count for that? And you have
And
to forgive me. Sorry.
The reason you wouldn't do that is because by moving to a different location, you are now following the curvature of the Earth that's built into Stellarium. And
That's what I'm saying. That's what I'm wanting to correct for.
Well, right. But if you correct for the curvature of the Earth, what you're going to find is it's telling you the Earth is curved. So what you want to do is eliminate all of their corrections for everything. You want to eliminate their correction for the curvature of the Earth by telling it you're looking from a mountaintop, so you're not going to deviate from that mountaintop because you don't want to follow the curvature of the Earth and get their fake corrections for the curvature of the Earth. And then you also don't want their corrections for where the star actually is, because if you just turn their corrections off, you have the actual uncorrected location of the star. And so once you have that, then you can trace the elevation of the star to the peak to your location, and it has no corrections for curvature of the Earth, and it has no corrections for refraction. You're just looking at the true location of the star from where the observer is seeing it disappear.
And you're right, 50. Like on a globe, there would have to be corrections every time you moved. The reason that this is useful is it basically forces the line, so to speak. It forces the line to take one angle at two different locations. And if you're able to do that, then it shows that the baseline's not curved, because otherwise you can't force a line. So he's got two different locations tracing the same line and the same angle using the mountain as a ruler.
Yeah. Yeah, this is an interesting method for sure. I wish I had seen the presentation. I feel like I'm missing some minutia detail, but it's definitely an interesting method. I'll give you that for sure.
You didn't see the presentation?
I didn't. I just missed it, man. But
Just go back and watch it.
yeah, I will. But I give you that. It's a neat method.
Technically, you could work backwards and do it the other way if you wanted. And Dr. Mike, maybe you could do that soon, like from a different mountain. If you get, I mean, I know, we're not bothering. You don't have to, but you are retired. If you wanted to do this, you could start from the mountaintop, right? And you could just pick a star from a mountain, pick a time, and go to the mountaintop and say, here's the angle to that star at that time. And then go to a location on the ground and say, okay, this should be the time I see the star occluded. Right, because then you're using the reference point of the mountain as your starting location instead of your house or whatever.
Yes, that's how I found where the stars should be occluded on Blodgett Peak. Blodgett Peak was challenging because it's so pointing. So I actually told Stellarium I'm on the top of Blodgett Peak, and here's my final bearing, and here's what I think the elevation will be. Now tell me which stars are hitting the peak at those coordinates. And then after that, I knew the time frame the stars would be hitting that would be accurate enough. And so I just set up the camera to record the stars during that time. And after the fact, I checked to see if they matched. And that's how I got the data for Blodgett Peak.
Oh, wow. Yeah.
And what I was going to say before is you gave an excellent description. So, and if you can find my presentation on Globebusters episode 13.6. Tizo has a much better presentation than mine, and I don't remember where that is, but he can probably chime in and say where his is.
Oh, I have no idea. You probably talking about, I was probably just explaining something to Alan and he recorded it, to be honest with you. You have to ask Alan. Is Alan in here anymore?
It's on.
That's probably
his
true.
he's gone.
I just thought you did it much better than I could.
Oh, well, I appreciate that, man. Just trying to use the KISS method, you know what I mean?
Yep, you all know I have this problem because I'm looking at things from so many different directions. I have a bad tendency to say the opposite of what I mean on occasion. And the other bad tendency I have, my professors always told me I took logical leaps. So they could not follow my logic because what I thought was obvious to everyone, they didn't understand unless I explained it to them in meticulous detail.
A more granular approach instead of just getting there already. Yeah, I get what you mean.
Cool.
Well, I'm also going to bounce out of here, boys, and I think Alan's done. He already bounced out. He finished the stream and dipped out. So it was a pleasure, guys. Thanks for coming through, Dr. Mike, and sharing with Geo's people. Sure, it's a
Happy to
benefit.
help.
Y'all have a good night.
Thanks,
Shane,
Diego.
Beasticles, all of the rest of y'all I know in here. Y'all have a good one. God bless you and follow Jesus.
Yes, sir.
Good night.
So does nobody have a problem with setting Stellarium to a mode that does not match observable reality and then calling that accurate?
The point you're missing, and this is an extremely important point, what Stellarium is telling you is the true location of the star from the peak that occluded that star.
So if I had been standing on that peak with my half-second accurate Theodolite at that very moment in time, what would I have measured? The 231 or the 246?
So that's the problem with trying to measure things with terrestrial theodolites is you have to deal with refraction and you have to make corrections. And what Stellarium or your favorite astronomy tool does is it eliminates the need for all those refraction corrections because it tells you what the true elevation of the star is from that location.
Well, if we can't test a software tool, we can't trust it, right?
You're still missing the point. Thousands of observatories all over the world have made the astronomy tools extremely accurate about telling you where the star really is. And no measurement you can make, even from the world's most accurate theodolite, can compete with all of those observatories.
So did they make it so that Stellarium tells you where the star actually is or where it appears? Because you have to point your telescope where it appears, right? If you point it where it actually is, you might not see it, right?
From what I've observed is at low elevation angles, Stellarium is not very good about telling you where the star actually is. But Stellarium and many other astronomy tools allow you to turn off the corrections. And when you turn off the corrections, it tells you where the star actually is, which may or may not be where you see it.
So I guess let's say at 25 degrees up in the sky, 26 degrees. Would Stellarium tell me the the angle that I would have to point my theodolite to line up to it, or the actual angle?
So the problem with theodolites occurs at elevation angles. I'm trying to remember where it starts deviating the most. I think from 15 degrees downward, it gets progressively worse due to refraction. And so it's the low elevation angles that tend to be the farthest off on theodolites and telescopes. And so that's the advantage of looking at those extremely low elevation angles with this technique because it kind of highlights how inaccurate the corrections are and how precise the celestial theodolite concept is.
So does this refraction at low elevation angles cause things to appear higher than they are or lower than they are?
According to G.G. Bennett and his 1982 paper, he says that it makes things appear higher than they are, which means whatever you measure it at, you need to subtract its correction allegedly to find the true location. What I discovered is, even and what he did, before I say what I was going to say, what he did is he was observing people's corrections were all over the place. They didn't agree. Many of them were really wrong, and so he was trying to come up with one equation that would be pretty accurate for all applications. Even his equation just varies because it's affected by temperature, pressure. Some people argue it's affected by relative humidity. Truly, there are so many corrections necessary to accurately measure a low elevation angle that that's truly what motivated me to eliminate all the refraction corrections by finding this two-step process to make it totally irrelevant.
I was interested in that. And you mentioned that there was that you could see the visitor center lights on the mountain too, and that they were at the same apparent elevation angle as the star at the moment that it clipped behind the mountain. So how could, well, is refraction going to be affecting the light from the visitor center lights?
It will be. Refraction affects everything, which is why we want to eliminate it. And it doesn't necessarily affect it the same on the visitor center side of the peak as it does on the other side of the peak. So that's why the important thing, what you're really after when you're observing stars be occluded, is you want to accurately record the time the star disappeared. Plug that time into your favorite astronomy tool, and then see what the uncorrected elevation of that star was at that time, and that tells you the elevation you can compare to the flat Earth prediction or the globe Earth prediction.
Okay, so the astronomy software brings up a really deep problem here. It's just a big black software blob. I didn't write it. You didn't write it. We don't know exactly what goes on in there. It gives us a number. In order for us to be able to trust it, to know that it's 2 minutes or 2 degrees and 31 minutes is even accurate, we need to be able to test it against observable reality. How would I go about testing it against observable reality?
So a very inexpensive, I think they're $500 C-Star S50 telescope. You can tell it track this star as it crashes into the peak and watch where it disappears. And from how well it tracks it, you'll know how accurate the database was.
Well, we know that stellarium can point to telescope, but how do we know what the exact angle that the telescope is pointing at? You see,
now you are beginning to realize, I think, why I came up with this celestial theodolite concept. Because you may not know where your theodolite's pointing, your terrestrial theodolite. You may not know where your telescope's pointing, but you know where that mountain peak is. And if you're observing it occlude that star, now all you have to do is see where was the star from that peak. You know the actual elevation. So think about that concept long and hard, because I've observed probably hundreds of stars now, and they're all within a couple of arc minutes of where the predicted elevation is, and there's a 27 arc minute difference between the globe Earth prediction for Pikes Peak and the flat Earth prediction, and for Blodgett Peak there's a 19 arc minute deviation. So there's your elevations you're getting out of your astronomy tool are way more than accurate enough to differentiate to see which prediction appears to be correct. And that's where, to my surprise, I found out it was the flat Earth prediction that was correct.
So I'm trying to understand how sighting the star over the mountain will eliminate refraction. If the light traveling from the visitor center to the observer is being refracted, and the starlight is shooting right past the visitor center at the same height, and that ray of light is then taking the same path to the observer, and they both appear at the same elevation angle, how can one be getting refracted and the starlight isn't?
So you're very confused because you don't realize that's what happening is the visitor center or the peak is occluding the star. So when it occludes the star, you know the starlight is not scooting past peak. Whatever refraction there was has just been eliminated at that second in time. And that's why at that second of time, you want to check the astronomical database to see what was the true elevation of that star. And that's the elevation that some would say is a coincidence, always happens to match flat Earth prediction.
So the ray of light just the moment before, are you saying the ray of light from the star just the moment before it gets obstructed suddenly becomes straight between the mountain and the observer?
Oh, no, that's not at all what I'm saying. What I'm saying is at the moment after it disappears, you know for a fact the mountain peak occluded it. You know the elevation and location of that mountain peak. So you can calculate what that angle of elevation should have been on a flat Earth or on a globe Earth. And at that instant in time, you can see where the astronomical database says the actual location of that star was. And you can compare that elevation, the predicted elevation, to determine whether it was a flat Earth elevation or a globe Earth elevation. And somehow, that always turns out to be flat Earth elevation.
Well, so far I've only had a chance to look into this one data point, and it also matches the globe Earth prediction exactly. But I think we've not been able to answer how can I test.
So you are actually being intellectually dishonest now because it does not match the globe Earth calculation unless you turn corrections on. If you compare the true location of the star to globe Earth elevation, you'll find they are different.
I'm not being intellectually dishonest. If maybe I did my math wrong, okay? I'll be glad to go over my math. It's pretty simple. But that's what my math says. My math says that for a radius of 3959, if you get 31.5 miles closer at 69 miles per degree, the elevation angle of the star will go up 27 arc minutes, which is exactly the difference between the unrefracted stellarium prediction from your house and the unrefracted stellarium prediction at Pikes Peak. So
let me be kinder and gentler and not call you intellectually dishonest. What you're doing is you are scooting the location along stellarium or the astronomy tool's presumed curvature of the Earth, thereby changing the measurement to what you want it to be rather than what it actually was.
Right. When you're changing the location, see, in the flat Earth, we're saying that it's optically going down. On a globe Earth, you're saying that positionally, it is actually changing angle because you have rotated or you're on a different part of the Earth.
So is it not true, though, that moving towards the star 31.5 miles would cause its elevation angle to rise 27 arc minutes?
On a globe without any what do you call it? Without any optical change of the star, like if like a street light, right? But on a globe, it's because you've physically either rotated or because you're on a different place on the globe.
And I
We're
also
saying
think
we're
you're a little
saying that something optically goes down because on a flat surface, something that's further away is just further down.
And I think you're also a little confused about how much impact moving 50 kilometers closer to a star that's at a minimum of 2.4 light years away would have. You won't even be able to detect the difference.
Well, if you're on a surface with a 3959 radius, then it will be 69 degrees or miles per degree. That's just
Only if
geometry.
you're a curved surface, then that's what you're not. So you're really, really confused about the concepts. And I'd urge you to try to steelman the other position, because to make your method work, you have to change the position where the star is being occluded to this position where it's being observed. But when you're changing it to the position that's being observed, that's not what's occluding the star. It's the peak location that's occluding the star. So that's where you have to get your elevation, not from 50 kilometers away or whatever, however far away the observer is, because that's going to skew the apparent angle. It's going to skew the angle the astronomy will tells you, because it assumes you're on a globe Earth.
So the problem is, though, that if stellarium gives out the correct angle at your house, then it should also give out the correct angle on the mountain. And the difference between those on a globe will be 27 arc seconds.
The difference between those is the 27 arc seconds that it assumes the globe is tilting away, and that's why it gives different measurements. And that's why you have to read the elevation from the location that actually occluded the star, not from the location where you saw the star disappear.
So that's still a problem. How do we know that that's actually the angle to the star if there's no way to test it? I mean, can I take my theodolite out on a clear night and measure the angle to a star at a point in time and see if it matches what stellarium says? Or will they never match? Because otherwise, we're just trusting some software that none of us wrote. We don't know how it works. And if we can't test it to be reliable to reality, then we can't use it as evidence of things. Right?
So you're still misunderstanding. Take 3 different observers, all observing the same peak occlude the same star at the same time. Let one be 25 kilometers away, let one be 50 kilometers away, let one be 100 kilometers away. Find an altitude, put them on a stepladder or building if you have to put them so that the predicted angle is the same. You will see them, all of those angles be the same angle.
To a star?
Even though they are different distances away on the supposedly curved Earth, they will see the same star occluded by the same peak at the same time if they have the same predicted angle to that peak.
I'm not sure how I would use that to test stellarium to know that it was giving me true answers.
I told you how to test stellarium. Have your telescope track that star, and if it can track it, it is apparently correct.
Okay, so do I turn refraction on or off for that in stellarium?
It sounds like now you are trying to bring refraction back into it, because refraction is the only way you can fake curvature of the Earth.
Well, no, because even with refraction turned off in stellarium, it says the mountain was 2 minutes 5 or 2 degrees 5 minutes, which is even lower. So
Not the mountain, the star.
Turning refraction off does not make it match flat Earth if you're doing it from your location with stellarium.
So I think you missed that point that he just said, is that you're not measuring mountain, you're measuring the star. Stellarium's telling you where the star is. The mountain is occluding that star, and that's how you know what time to look at the actual elevation of that star with no corrections applied.
Well, but it still requires using stellarium without being able to test stellarium.
So you're now engaging in a circular argument, which I guess is probably appropriate for people who believe in a circular Earth.
Hey.
You can't. It seems like you're unable to explain why the celestial theodolite technique works. You're just trying to change it with your conception of the curvature of the Earth.
Well, remember the flat Earth mantra is don't trust anybody. And so, if a guy says, "Oh, I got this scale here, it works," and I'm selling you this something, you might want to take your own test weight and put it on that scale and make sure the scale is actually right. If we can't test the output of this software blob against observable reality, we aren't going to know if it's telling us observable reality. And the problem here is, when I turned atmosphere off and pointed my telescope where it said to point it, I didn't see the star. When I turned atmosphere on in stellarium and pointed my telescope where it said to point it, then I see the star. So, from my personal experience, stellarium does not give you the accurate angles to stars if you turn off atmosphere.
From a mountaintop? Are you on a mountaintop?
And I also think the other thing you're missing here is that you're basically making the point that refraction skews where everything appears to be, and you're denying the incredible coincidence that this incredibly inaccurate, as you call it, astronomy tool agrees with the flat Earth prediction every single time.
Do you have
I want to try this one time, because I'm probably the one person in this room that has I don't have as deep an understanding of the whole thing, but I really feel like I've heard it so many times. He's telling you that if you take an angle measurement from his house to that mountain, okay, he comes up with 231. All right. And then he's sitting there and
I actually want to
he's
refute that right now. So I'm saying, yes, you can make that angle measurement, but that angle measurement will be skewed by refraction. So you can't use a single data point, and you can't even use an optical measurement that is subject to the influence of refraction. And I'm sorry for interrupting you, and go on and make the rest of your point.
Oh, well, I mean, I thought the important part is that you can actually sit there and you can pick a star and wait for it to occlude. Wait for the mountain to occlude that star, and you can mark down the exact time. And then it just so happens that you can go into the stellarium and get an elevation angle to that star from that mountain uncorrected, and you get a line from the star to the mountaintop to your position, which is a straight line.
I think you stated that perfectly. And the only thing I was disputing is, don't ever make a measurement with a terrestrial theodolite because the chances of it giving you an accurate measurement are near impossible because it has to be corrected for so many things when you're measuring objects that far away.
No, we're not making corrections, Mike. We're just measuring the raw angle.
What you're missing, Rue, is you are making measurements, and those
I'm not
measurements
making
are.
corrections to measurement.
If you don't make corrections, you won't get the same angle any 2 hours, any 2 days.
Oh, we're making a raw measurement to the angle. My prediction, right,
So
is
give
on
me
a
a list of
globe
your
and
raw
incorporates
measurements, hour
refraction.
by hour, day by day.
Hang on.
I want to see that list.
Yeah, I will show you a stack of my measurements if you like. Would you like to see them? I've got videos.
So actually, I don't really care to see your
There you go,
measurements
right away.
because I know they're inaccurate.
Okay. Of course you do. You haven't seen them, but you know they're inaccurate. Got a lot of
And I'll
fluff.
tell you why I know they're inaccurate. Theodolites are incapable of making accurate measurements over long distances without corrections. That's why surveyors take such extreme care to cite their measuring rods, to reference themselves to markers. They cannot just set a theodolite up any place they want to and make an accurate measurement that is repeatable as the temperature and pressure and relative humidity change. Those measurements all fluctuate throughout the day. And when they begin making corrections, if you
We're not making
carefully
corrections.
look at, okay, and if you're not making corrections, you're not getting an accurate angle.
I'll say this as plainly as possible. The angle is what it is. We point the theodolite at whatever we're looking at, read the number off the screen. That is the angle. We're not correcting anything.
Are you
Cool.
aware, Doctor, that even in the raw measured angles, there's still missing height that conforms to a sphere? I tagged you. Oh, go ahead if you're going to speak.
I was going to speak. Yeah, it just took me a while to hit the microphone button. I'm very, very well aware of the limitations and problems with theodolite measurements, which is why I came up with this technique of using an actual known mountain peak to occlude a star so that we knew when the star disappeared. And then looking at what an astronomical database said was the elevation of that star. Once we know the true uncorrected elevation of that star, we can then compare that to what flat Earth predicts versus what globe Earth predicts. And the problem you're all facing is that it agrees with the flat Earth prediction every time, and it never agrees with the globe Earth prediction. And we can argue this endlessly, and this is I'm perfectly willing to help people understand something, but I'm not willing to endlessly argue with people who refuse to understand the differences between our positions and what each position states, and want to keep skewing the argument into correcting for the globe Earth, disregarding how the astronomical measurements tell us that those measurements are skewed. And I'm sorry to all, but it's past midnight where I live, and I have to get up at 6 a.m. to feed the rescue dogs. I'm gonna have to leave you all now.
No worries,
And
Dr. Mike. Thank you.
all right,
Yeah,
thanks for having my back, guys.
Yeah,
All
man.
right,
And
good night, Mike.
I'm confident. Good night, Rue. And thanks, and I forgot to thank you, Rue, for blurring. Thank you for blurring numbers on my sign, and you do make a lot of valid points. We obviously have a difference of opinion, and I hope we can all converse with each other in a calm, gentle manner and do our best to see things from one another's point of view. And science is all about trying to refute the null hypothesis. So I urge everybody to work on that concept. Apply the scientific method as best you can, and I think eventually we'll come to a truth that we can all agree on, or we'll point out each other's mistakes as the case may be. Good night to all, and thanks for having me here.
Good night, Dr. Mike. Get some rest,
Yeah,
brother.
Thank you. Yeah, cheers.
And
that was
see
fun.
See if you can strawman my position and come up with what would the predicted globe angle be for Stellarium on that mountain peak on a globe.
Steelman.
Straw or
Oh
steel?
yeah, Steelman. Yeah.
Steel. Right.
See if you can strawman it.
Oh, what's the difference, really? Does anyone really strawman? I mean, Steelman.
Well, I said they put the observer somewhere else, and I got accused of making a straw man. And then, was it Pizzo? Someone comes in and goes, oh, yeah, so we moved the observer. And I'm like,
Yeah, there's two positions. There's two positions. It's not really moving it. It's just 2 points of reference, which is why it creates, like I was saying, it's almost like creating a ruler from the ground to the mountain peak to the star. Right. It's creating like the first notch on a ruler in a way.
yeah, but they accept that they accept the angle from Stellarium, right, in one location, and then ignore it from and basically it's wrong from another location.
Well, the whole point is the physical difference. If this can be replicated from one point and then another point to a different place, another point, if the mean average is that you're creating a straight line to the sky with a flat Earth assumption, then there is no rotation and there is no changing of angle because you're on a curved surface. So that doesn't even apply to this theory, this like hypothesis.
Okay, I'll tell you, and probably Jesse will tell you as well. Stellarium is incredibly accurate with refraction. I'll go out and measure a star tonight.
Well, that's fine, but acknowledge the point that I just made. The hypothesis is that on a flat surface, something's going down because distance is changing the angle. But on a globe, the stars are going down or around because you're on a curved surface.
Yeah, it's a change in orientation. Yeah, so it's not.
Yeah, it's a total orientation change. So it's a completely different hypothesis.
Yeah.
So like changing the location, looking at something, isn't going to. That's not going to prove it one way or another, and that's not going to argue in your favor. What is going to do it is to everyone go out there and do their own observation and see if this hypothesis even holds up. And if it does, then the flat Earth is the strongest position.
Yeah, but what happens when we go out and measure the mountain properly at 219?
Just find out. Just find out.
And matches the
Just find out.
Yeah, I plan to.
He's giving everyone license to take their gun and go hit targets. Okay.
Yep.
So
I can't do it here though. It's rubbish in Sydney. But maybe I can find a spot.
Oh yes. Yeah.
You all right there, 50?
Oh, I'm sorry.
Your mumble
Chilling,
bro.
Jesus, I don't even want
Talking to
know
myself.
what that was.
I was muted.
Yeah.
Remember when I said the next concession after the quote unquote final ridiculousness that went on of the Antarctica thing, but like the Globe folks somehow felt like it was some kind of a dude. Like I was saying, like dude, like even if you felt like that was some kind of little minimal thing that was, if you want to call it that, like in terms of some kind of effect or whatever. But what I'm saying is that like, dude, the next like series of things are going to be concessions. on the other side, you know? Like, yes, there is a 24-hour sun there. Some people said there wasn't. Okay, some concession, I guess, of whoever said there wasn't or whatever that there is. But that's pretty minor and obviously didn't really have any effect on anything major. But I guess what I'm just getting at is that, like, something like this, like, is being discussed, dude, if this is replicated 10 times, 20 times, 30 times, 50 times, 100 times, hundreds of, you know, and then people can replicate those from those positions as well, that is a massive data set. And granted, it is doing an observation in the sky in general. However, in terms of what it entails, it definitely seems like it's in, like, you know, somewhere in the top list of things to do with the sky in terms of trying to get some of the geometries, because you're using a point on Earth, like the peak of a mountain, to relate directly to the sky. The sky is consistent to a degree, obviously, like in terms of its consistency and the timing and how this is all, you know, how these geometries come together, because it's an intersection point of the ground and the sky. Therefore, there's going to be a geometric relationship.
Yeah. Can someone steel man something for me as well? So the whole geometry is that he's drawing a straight line back from the mountain to his house, but then he'll say straight up that, you know, refraction changes the apparent position of the object. How does that work?
Did you say steel man your position, or are you asking
Well,
a
steel
question?
man his position. He seems to reject refraction and then acknowledge refraction. So which is it?
I'm not sure about the refraction, but I can say that basically the way I understood it is that I can take my camera and I can go and get a distance from me to a mountain, and I can just stand there and wait for a star that I've identified what star it is, and I can wait for that mountain to occlude it and mark that time.
Yep.
And then using that information, I can go to using that time. I can go to Stellarium and ask it for an elevation angle to that star from the mountain, uncorrected. And then I can get a point from that star to the top of the mountain, and it will draw a straight line to my position.
Yep.
I don't have to do anything else.
Yep.
That's the question.
I'm just an average Joe Schmo that's taking a picture or taking a video of a star being occluded at a specific time by a specific mountain peak while I'm a certain distance away.
Yeah.
Right.
So the question is, you're drawing a straight line back from the mountain to your observer position.
No,
ignores
I'm
refraction.
drawing a straight line from the star to the mountain peak to my position.
Yeah, straight.
I'm using two reference points. I'm using the star and I'm using the mountain peak. That's the 2 points that I'm using.
Right,
And
but
when
it's
I
straight,
check with
right?
Stellarium and I have an uncorrected, not accounting for refraction, where you think you would see the star, but where the star actually is, it draws it. It is a perfect point from the star to the mountaintop to my position.
Right, but
Yep,
straight
you
means
got it.
no refraction.
Right.
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 But then Heffron will say, yes, refraction changes the apparent position of things.
Of terrestrial theodolite observations. Listen.
Yeah, under 15 degrees, like refraction's much more of an issue.
And distance.
Hang on.
And if you're just getting if you're getting the planar one after the other, you're getting that. It's like, what is the refraction perfectly just fitting planar by coincidence every time? Or is that
Right.
foundation just planar?
Right.
It doesn't match, right? The globe prediction for no refraction is 217. With
That's the
refraction
point.
is
It doesn't
219.
match globe prediction. It matches a planar
It's calling the bluff.
trig
No,
position.
his transit measurement from his house to the mountain, he measured 230 and predicted 231 on a flat Earth. I agree that is consistent with the Earth being flat, right? His measurement matched his prediction. What I'm saying is his measurement is inaccurate.
Yeah, I know. That's all you could say. Measurement error. That's all you got.
Yes. Because
Okay.
guess what? The globe prediction with refraction for the mountain is 219, and the star prediction with refraction is also 219. They were occluded at the same time. Same angle, yeah.
All right, so Ruha, if you're saying your general prediction that if this is repeated, 10 times, 20, 30, 40, all around the world, you think they're just going to be getting globe, left and right? That's your prediction? Because if it's the opposite, then what?
Yeah, evidence for flat Earth, sure. But what happens when the survey goes out and measures 219 or 220 from the benchmark? What happens then?
Yeah, but he's already taken hundreds of these himself.
Has he?
Yeah, that's what he claimed.
Okay,
from
with
two
his,
different mountain peaks.
With stars, not with
not with his
With stars.
theodolite.
The point is,
Not
a
with his transit.
theodolite.
He's not using a theodolite.
A transit, sure, whatever.
He's standing somewhere watching a mountain occlude a star. He writes down precisely, exactly what time that star is occluded, and using an elevation angle obtained through stellarium. Okay, which is what? Nothing but a massive database of much better measurements than anybody here is going to make with a theodolite. Okay, he's getting an uncorrected position of that star. In other words, let's not account for any refraction whatsoever. And it just so happens that doing that without using any theodolites or anything else, that a line from that star to that mountaintop leads directly to his position each and every time. Each and every time.
Question.
That's
Question, is stellarium accurate when he looks up that angle? Is it correct?
Well, if you want to say that stellarium's incorrect,
I'm asking you.
I guess you can go about it.
I'm asking you, when you put yourself on that mountain, does it give you the correct angle? Is stellarium in general correct?
It's the best database we've got, I guess. Fine.
Excellent. So if I'm looking at a star from his house, stellarium's prediction, without refraction, because he ignores refraction, the prediction from his house is 206, which is way off his measurement.
Yeah, but that's taking into
But
effect.
he's not even using that.
Right? Why not?
Right?
Why isn't he using? Why is he saying that's wrong if you just put the observer at his house?
No, what he's saying is that if he just watches a star get occluded by a mountain, he can literally go to stellarium, get an uncorrected angle to that star, and a line drawn from that star to that mountain peak goes directly to his position.
Yes, I
He
understand.
doesn't need an elevation angle to the mountain.
No, you're missing the point. You are accepting the angle from stellarium, correct? You're accepting that angle as correct.
We're using it to test against.
Right.
He's going to
okay. Well, so what? So what?
An uncorrected for refraction, right? Uncorrected. Yeah. So yeah, that's exactly where he's getting it from. So yes.
Right. Okay. So stellarium is correct when you put him on the mountain, but incorrect when you put him where he actually is.
Okay, listen. If the star is at 2 degrees 4 or 2 degrees 6 arc minutes from the house to the star, how can you verify that if you can't see the star? If you can't see the star.
Well, then it's already occluded, right? Be behind the mountain much
So you
earlier.
can't verify that, so it's not relevant.
How about I just measure it at occlusion at 219? It's not at 206 then, is it?
I mean, you do agree that if the star is blocked by the mountain, it is physically being blocked, and that above the mountain, it is the refracted position.
I'll share
that once it's behind the mountaintop, it is completely obstructed by Earth.
I'll share my screen. One sec.
Yeah, because
So
a
now-
refracted
I
mountain
mean-
can't block something. A refracted mountain.
I mean, once it's blocked,
blocking the light.
just yes or no, man. That's all.
Right. The path of
When
light
you're
is
seeing the
curved.
star, that whole image is refracted. But then once it's behind the mountain, it's obstructed by Earth. Yes.
The path of light is curved, and that path hits the mountain. That causes the obstruction. It's not a difficult concept. Look at my screen.
We
So
got
when you're talking about
we got
apparent
a Limpy. We got a limpy
Sorry?
light path here. We got a limpy light path.
I know it's ridiculous.
Flaccid light path. But yeah, this is how much this little area or height in here. That's how much the star gets refracted. The mountain gets refracted up. This is how much the star gets refracted up. This is where you see the star. This is where you see the mountain at the same angle.
Yeah, this is
This
sort
should
of
be
like almost a
pretty
different argument, like because I hear you, but I mean this is the thing. You need to bend and warp things to fit the globe. I mean we get it, but I think part of it has to do with what the actual just direct observation is empirically, directly from reality. I mean because this is like a separate thing. I mean if you're just going to make a curve and say therefore globe by using various assumptions of how light's curving without an actual measurement of the light curving and just a kind of a model for it. We get it. We've been through all that, but it just doesn't really address the actual point at hand directly.
Well, he already conceded that if the point that Dr. Mike is bringing up is consistent to pretty fair degree, then it is flat Earth evidence. He already said that. So
yeah.
If a survey goes out there and measures 231, I'll go, yeah, that's a point in your column. But guess what? He's not going to. He'll measure like 219 or 220.
Just go do it somewhere else, Ruhif. You don't need to invade someone else's private place.
The great thing,
he said no. He said no to going on his property. That's fine.
The great thing is that we don't need your paid guy to do this. Anybody can go do this. So
really,
not
yeah. All we need to do, man. All we need to do is make sure that this thing is obstructed by something, and then test it against the stellarium. That's it. Right. Now, not to say that we shouldn't go on top of mountains and verify the angles, but as far as the model's concerned in stellarium, if this holds true, that's very interesting.
Right, but given that both Jesse and I have done a shitload of measurements, first of all of stars, the refraction correction in stellarium is necessary, otherwise you won't be pointing at the stars. And secondly, we've done a shitload of measurements with theodolites, and there is missing drop.
Okay, well, you're presuming physicality. We're not. So
physicality to what?
You're, that you're going around a curve, which is changing position of sky objects. So we're not doing that.
All right.
Didn't Dr. Mike say that the one thing with the theodolites, and I could be getting this wrong because I don't know it that well, but it seemed to me like he was talking about when you apply celestial refraction to your measurement, you come up with 231.
Yep.
It's only when you apply terrestrial refraction that you get 219.
Right. Why would you
But then
apply celestial refraction?
You're applying celestial refraction for the star and terrestrial refraction for the Earth.
Yes.
Yes.
Like two different types of refraction to match.
No,
the angle.
not two different types. Two different distances.
It's still two different
Stars
types.
are farther away than the
Not
surface
two
of the
different-
Earth.
It's not two different types.
So now
Two
I'm
different distances.
wondering what happens when I get really close to the mountain.
Yeah,
Like
would you apply celestial refraction?
Like maybe 3 or 4 miles from the base of the mountain.
Right.
And I'm looking at angles high in the sky. So are you going to apply terrestrial refraction to the mountain now?
I'm always going to apply terrestrial refraction to things on Earth and always going to apply celestial refraction to things outside our atmosphere. Why would you apply 15 arc minutes of refraction to a mountain in front of your face?
I'm just wondering how close I got to get to the mountain to knock out refraction, terrestrial refraction.
You can't. That's
Yeah,
why
you can't
That's why Dr. Mike used the celestial theodolite.
So I can literally use terrestrial refraction to say that my refrigerator isn't where I see it. Is that the idea?
Yes.
Yeah, technically
The house
speaking,
next door to
it
me
would be
is
displaced,
technically
yeah.
not where I see it, right?
Yeah, Kembo, it's an unfalsifiable assumption of refraction.
Can Ruhif respond or not?
Yeah, technically it will be displaced by fucking, I don't know, what's the smallest angle? Nanoradians or whatever.
However far down you can get where it's not
they're negligible.
This again is just like when I asked you about an equation so that I can work out how far I'm going to see on any given day. Your first response was to take me up above 1,000 feet where
There's less
where
refraction.
refraction
Not less
stabilizes,
refraction.
and you can just claim 7/6R, which was not the question that I asked. The question that I asked was, how can I go to the beach with a camera, and what equation can I use to predict how far I'm going to see on any given day at any given time?
Right. I already answered
I didn't
you.
ask
If
you to
you can,
take me up to stabilized refraction where you can just say, oh, well, it's 7/6R.
right.
I
So I've
asked
already
for,
answered you. Yep.
no, you didn't answer me.
No, I said you need to measure the conditions accurately, and then I will give you a prediction.
No, you didn't. You said, well, yeah, I can predict it. If I get up there, actually, at first you started off with high altitude balloons or satellites, but then you said as long as you're above 1,000 feet, refraction stabilizes at 7/6R, and I can predict how far you're going to see. You never said, yeah, you can give me these varying conditions while you're at sea level, and I can predict how far you're going to see.
It's literally an input in Walter Bislin's calculator. You put in the conditions.
Yeah. Well, once you get well above the surface, and those conditions are stable and predictable.
So when somebody has a 31-mile observation
At the
and
surface.
the terrestrial, at the surface.
Yep.
Okay. And you have a terrestrial refraction value of like over 4,000 over 6R.
Okay.
So that you can make this observation. Exactly how are you computing that?
Right. We're measuring, well, if someone actually measured the conditions, we would be able to calculate the gradient and then tell you what
Well,
over
I'm
6
pretty
are you
sure
like.
I'm pretty sure BLMSB 69 records all that information.
No, he doesn't.
And a gradient?
Yeah, that's the key. The key thing is not just to measure the absolute temperature and pressure and humidity, it's to measure the gradient. How much does it change as you get from low down to high up? Right? There's only
How
one.
would you even do that?
So something that
do it.
you can't actually do.
Yeah,
Yes,
how
you
would you
can.
even do that?
FE Core has done it. FE Core did it.
Right. Why can you? Okay, I want to know what you think a gradient is and why it's not measurable.
Okay, I'm asking, how would you do that? How would you measure the gradient?
Yeah,
You
take
measure the
temperature,
conditions
pressure,
at different points along a vertical, a vertical
Yeah,
column.
how would you do that?
You measure
Yeah, how?
pressure and temperature along a
Using
vertical
what?
column. That's it. That's all it is.
thermometer,
It's
please.
not
What's the
complicated.
thermometer?
At every so what? You'd have like a weather balloon at the edge of like your target location, and you let it
Hang on.
go up and measure a gradient. Like I'm trying to figure out how would you actually do this?
I'll tell you what FE Core did. They measured the temperature, pressure, humidity at like right at water level, and temperature, pressure, humidity at 2 meters, I think it was. And I ran those numbers through, through the formulas, and that gradient between 0 and 2 meters would have bent the light more than the curvature of the Earth. So you'd probably look concave if you could see the other side.
Ever so slightly.
Yeah.
So just again, refraction basically just gives you guys an unfalsifiable position.
Close to the surface, yes. Get above the surface where it's
So you
stable
admit
and
it's
predictable.
unfalsifiable at the surface. So there is no way, Ken, to answer your question. It saved you a bunch of time.
Oh, I know he didn't answer it the first time.
Get away from the surface.
He just wanted to get away from the surface, get up 1,000 feet, and it stabilizes at 7/6R.
There was an answer. I just gave one. That Ruhif gave one. Don't say there isn't an answer.
Yeah, so if I have a 31-mile observation that I'm going to make that I can't predict ahead of time, because logically speaking, to go all along that 31 miles to get different temperatures, water temperature, air temperature, pressure pressure readings. By the time I get back, all of that could have changed.
Yeah, It's impractical.
Yeah.
Nobody said you had to go the whole
yeah, it's
31
extremely
miles.
Well, no, you want to go along, don't you? You want to know what it is, where it's going. You want to know conditions where you're viewing at. And the thing is you want to be able to predict ahead of time. So it's an actual prediction, not a post-diction where you look at, oh, this is where you were and this is how far you saw. Okay, now I want to know what the conditions are.
How am I meant to make a prediction without knowing the conditions when the conditions change a shitload close to the surface?
Well, that's just it. You can't.
Right. So we agree. We're in
Yeah,
violent
we
agreement,
agree.
right?
So
Right.
we
Get away from the
agree
surface.
that terrestrial refraction is strictly post-diction.
No.
That's all
Get
it is.
above the
It's
surface.
post-diction.
Nobody
and
said
it's
that.
stable and predictable.
Yes, you can post-dict it. You need to know what is being observed so that you can calculate the terrestrial refraction.
No.
It's
Put
the
me
only
above the
way you
surface.
get a value for terrestrial refraction. You cannot
False.
get a value of terrestrial refraction until you have an observation.
Incorrect. Give me any observation well above the surface and I will tell you what it would look like.
Well above the surface.
Yes.
We're talking about at the surface.
Right. Then I
Down where
can't predict
nothing
it because no one measures the
down where
conditions.
but see, the thing is you want it down low. Why? You
No,
want
I
it down
don't want
low
it down
because
low.
that's where the curvature is going to obstruct your view over a long distance.
I've said this a few times now, right?
So let's just go
Getting
ahead and
above
take
the
it up in
surface.
elevation to where it's not going to obstruct your view.
Right. Getting above the
Yes,
surface.
because to observe
is in
curvature, you
your
don't have
interest.
to have obstruction.
That's true as well. But getting above the surface is in your interest, right? Because if we're close to the surface and we see bottom-up obstruction, we're going to yell earth curve, right? But if we see no obstruction, we're going to yell refraction, right? You guys don't have a good explanation
So
for
you're
bottom-up obstruction.
right. So if you don't see it, you say, earth curve. And if you do see it, you, refraction.
Right.
So
Don't
you're
give
right
us that
no matter
excuse.
which one.
Right.
You're right no matter which one,
don't give
right?
us that excuse, right?
Yeah.
Don't allow us to do that. So get above the surface.
Well, see, the thing is if I can't see that far, I just say visibility's poor that day. And if I can see really far, I say visibility's really good. I can see a long ways across this plane.
That's not
So
bottom-up
I
obstruction,
should be
though.
right on both counts, right?
No, visibility to me means things fade out. Visibility to me doesn't mean bottom-up obstruction.
Right. Same for anyone
I can
else.
get bottom up obstruction on a flat warehouse floor.
Oh,
using
please show that.
painted bricks. People have done it. You could do it in your house on your table
And
using
what
much
is the
smaller
model?
objects. What do you mean? What's the model? Is your
What is
table
the
not flat?
explanation?
What do you mean?
Some
What's
tables
the
might not be flat.
explanation? If I can reproduce bottom up obstruction on a flat surface,
Did
then
you
it
say you
means it's
used a
not
table to do
exclusive
this?
to a globe.
Exactly. That's
Right?
exactly right, Ken.
Right. So you
Hold on,
remember
did
the
he say
old?
he used a table to do this?
You can
Yeah,
use
remember the old video?
You can use the garage. You can use the garage floor like Sky Free did.
Yeah, but a garage is flat.
The garage floor?
Yeah.
Yeah. Yeah, it's
How did you demonstrate that?
Oh my god, dude, it's definitely flat, all right?
If
It
you
was
pour
like
water,
20
where does it
feet.
go?
Bro, the point is it was reproduced at a small scale, which means bottom-up obstruction is not exclusive to a globe.
Right. So first of all, garage floors and warehouse floors are not flat. We all remember the dude who put his camera down on the football field and started walking away, and he disappeared bottom up. That field's not flat. So what is the geometry, physics, optics
Okay,
to
what about
explain bottom up obstruction?
What about the sailboat in the pond? Like Sky Free did as well. The little sailboat.
And I do not recall.
You can't
Did
you can't say
assume the
that
water was
water's
flat?
not. You can't, dude. You can't say water's not flat. Come on, dude. Don't say
okay.
that.
Okay, who are you
Like a globe.
talking to? If you think the Earth is, if you're talking to somebody who thinks the Earth is spherical, clearly they have to believe the water is not flat, right?
Not in a pond. It's a pond. There's no
so
curvature.
the only
you're talking
surface
about
of
the
water
one
that's
where-
flat is in a pond.
So you're talking about the one where where he used an RC boat.
Yep.
and the distance to the horizon for the camera height was supposed to be 2,800 feet, I believe. It was over 2,000. I think it was around 2,800 feet, and the little lake itself was only 1,000 feet long, or pond, whatever you want to call it. It was only 1,000 feet long.
Yeah.
So the distance across the lake was not even half the distance to the horizon, and yet the RC boat disappeared.
Okay. And
So
what was
you
the
didn't have bottom up
explanation?
obstruction due to curvature, because curvature was supposed to be, the horizon was supposed to be more than twice the distance the lake was, and the boat wasn't even on the other side of the lake. It's estimated that it was probably only 700 to 800 feet away when it disappeared. Not even the full 1,000.
Right. But was there an inferior mirage, or what
It's
is
bottom up obstruction produced on a small scale with a
right?
with a 1,000-foot lake. Okay, that
Yes.
means
Was
it's
it
not
was it an
mutually
inferior
exclusive
mirage?
to a globe.
Was it an inferior mirage? Oh, yeah. Carnivore says yes. I can't confirm or deny. But yes, mirages, like upwardly curving light, necessarily has a hidden zone on a flat or globe.
Okay, so it's not mutually exclusive. Thank you.
Okay, but when you've got upwardly bending light, you necessarily have a mirror image. Was there a mirror
Right.
image?
So it can be produced without curvature.
Right. So if I show
Which
you,
means it's
if I
not
show you an
mutually
observation,
exclusive.
That's
There
all
you
that
go.
matters.
Yeah.
if I
Not
show you an
mutually exclusive.
observation of
So you're
bottom-up
telling me that
obstruction,
on a flat surface, bottom up obstruction can happen.
if
Correct.
there's
That
an
you don't
inferior
need
mirage,
curvature
yes.
for bottom up obstruction.
If
And
there's
that's
an
all we're
inferior
looking
mirage,
for. Is
yes.
that,
But the question
that
is, if
that
I
it's not
show you an
mutually exclusive.
observation, if I show you an observation without an inferior mirage, but with bottom-up obstruction, what is the explanation?
Repeat that again.
So we both agree that regardless of flat or globe, that inferior mirages can cause bottom-up obstruction, but you'll have an inferior mirage, which is like a mirror image, right? So if I show you an observation without an inferior mirage, but bottom-up obstruction, so, the inferior mirage cannot cause the obstruction, what is the explanation on a flat Earth?
Well, that's
Or an
just a
inferior
hypothetical.
mirage.
Sorry?
You talking about what's the explanation for an inferior mirage?
No. There's no inferior mirage, right? We agree that inferior mirages can cause bottom-up obstruction, right? So if I remove the inferior mirage, there's no inferior mirage, then what is the cause of bottom-up obstruction? Check the chat.
Check the chat.
Yes.
Use the animated one.
You've this is a kind of a bit of a diversion from the celestial theodolite discussion, but
yeah, I'll duck
Yeah, they
out
don't
in
have
13
anything
minutes
yet,
anyway.
so we can't really talk about it.
Well,
I know
you've got my
it-
position.
Something.
So to say that we have nothing is pretty piss weak, by the way.
You literally said you don't have anything. You said it's a measurement error, so you're going to make your own measurements with a professional surveyor. So yes, you have nothing.
Right, the globe predicts 219 for both the star and the mountain, whereas Mike's predictions are just, I don't know, half a degree apart.
All right. Well, I mean, you've put your cards on the table, so
yeah,
that's the thing. They could get roasted.
See those
He
Sky
went
Free
all
videos.
in.
Where's Sky Free? Let's see here.
There's a flamethrower nearby. Your cards might get toasted.
Matthias KP, who put that there? That was Carnivore. Carnivore posting the ferry.
Thought I saved
we
Sky Free's
need-
channels. Do you
we
have?
need
No, really, because you're
explanation.
saying that the measurements should be different. They should fit the globe. So I mean, yeah, you're going with, the positions of everything as is, and you're saying it really just should measure globe. At a baseline. That's what you're saying, right?
Yes. Guess what?
All right.
It will.
But you don't have any data to show that it will, and he has data to show that it doesn't fit the globe. So there's that so far.
Yep. He has a measurement that matches close enough to the flat Earth prediction. 2 degrees 30 minutes.
Well, that's what I was saying. What do you have to rebut it? Other than like the kind of flabbergasted kind of response kind of thing. But like what like data? That's the thing. You need to basically go out in the field. Maybe get some data.
I'm trying to
rebut it.
Yeah.
The problem is
when
that
you say
Dr.
get
Mike's
some data. Yeah, Divis.
The problem is that Dr. Mike's own data calls that previous measurement into question. So he's got the transit measurement to 2 minutes or 2 degrees 30 minutes. And then he also has this observation of the star being included by the mountain. Now he's saying he doesn't want to use the direction he should see the star in from his house, but he wants to use the direction he sees the star in from the tip of the mountain. There's no real reason to use that measurement other than it matches what he wants.
Yeah, 100% Divis. Yeah, he accepts the angle when you stick the observer on the mountain. That's a correct angle, but it's stellarium somehow wrong when you put it where you actually are. Like it's pretty weak sauce.
Well, the reason he says it's wrong is because it's using the globe to move the star, but then the angle he gets from stellarium for the person standing on top of the mountain, stellarium is still using the globe, but it's no longer a problem because fucking reasons. Who knows?
Yes. Correct. Can I state my request again for someone to model the geometry, physics, or optics of bottom-up obstruction on a flat Earth when there is no inferior mirage? Or make a prediction for something like Canigou or San Jacinto as to how much should be hidden on a flat Earth.
Here on both Space Audit's channel and Shane St. Pierre, you can find videos about bottom-up obstruction.
I'm sure it could. Is there a
right? Is there an optical? Yeah, is there an optics model in there anywhere?
Yeah.
No, there is not.
Ooh, couldn't tell you.
Yeah.
There never will be.
Yeah, there'll be a lot of words. There'll be a lot of Rayleigh criterions thrown around, and field of vision and spherical fucking That'll get
spherical grid of vision now.
That's the one.
But you guys don't even take that into consideration. You just say, "Oh, Earth curve," but don't even take into account the like optics. Like there are limitations to optics.
Now hold on. Ruhif was asking, and I backed him up. I said, we need some sort of optics model for these observations to make a prediction. You're saying we don't account for optics. No, that's our contention. You can't turn that back on us.
What are you talking about? Dude, you guys say that because of Earth curve, things disappear, bottom up.
Yes.
Right? But don't take into consideration the limits of your vision. Ever.
Please model that. Please model that.
What do you mean model it?
Use those optics that you're claiming we don't consider to make a prediction.
You don't.
Right. Okay. Again, in order for your statement to have some level of validity, you need to use what you're saying to do something useful with it.
Okay. All right. Do you agree that there's a convergence point, a vanishing point, in anybody's observation, right? Using any optics, whether binoculars, your eyes, the telescope, doesn't matter. Do you agree that eventually, after a certain amount of distance, things will start to converge towards the middle?
Yes. Railroad lines, street lines, whatever. Yes, of course.
Okay. So how do you take that into consideration and differentiate between that limit of your vision and Earth curve?
Right. So we all
what you're
know
mentioning is perspective.
The street lights, right? The top of the street lights ramp down to eye level in exactly the same way as the bottom of the street lights ramp up to eye level. Agreed?
Wait, say that last part.
So the street lights, right? The top of the street lights ramp down to eye level, and the bottom of the street lights, like the bases, ramp up to eye level. That's perspective, right? On a flat plane.
Yes.
Yes. Okay. So the bottom of something ramps up to eye level, yet when I look out at boats, 40 kilometers away, my elevation is lower than the height of the boat, but the boat appears significantly below eye level. And the horizon appears significantly below eye level. And matches globe predictions.
Right, and just to make it, the point that I want to make very clear is you're asking people to consider perspective.
Yes.
When the predictions involved deal with the direction you have to look in order to see something. When you make a prediction for which way you need to look in order to see something, you cannot forget to account for perspective. It's not possible.
Right. So how
No,
can you differentiate?
as in if anybody makes the prediction, they didn't leave out perspective. It's actually impossible to give a prediction and perspective is not accounted for. There's no way to do that.
Yeah, exactly.
Actually.
Right. So how can you differentiate between the limits of your vision and Earth curve?
I just did.
Because perspective is not the reason why things are getting hidden by the surface of the Earth. Perspective is not the reason why things are dropping from horizontal as they get further away from you.
Couldn't have said it better. I'll show you the just a picture.
So it applies to street lights, but nothing else, right?
Well, technically, if you have
on a
street
flat
lights
plane.
on both, if you have street lights on both sides of you, they also appear to converge at a point in front of you. So it's not just up and down; it's also horizontally, right? Not just vertical; it's also horizontal compression,
Yep.
right?
And if you do the same thing with a tall building, you'll have the opposite. You'll have vertical compression. Like if you go towards a building, like a skyscraper, and you start looking at the top of that skyscraper, and you start walking towards the skyscraper, eventually it will disappear top down because it's a vertical compression because of the difference of the incident angle of your eyes, basically looking at the skyscraper. You'll start to see the top floors disappear first.
Hang on 1 second. This is one of my all-time best captures. 1 sec. I'm going to share this. 1 sec.
No response to that at all? You guys don't agree with vertical compression looking at a skyscraper? You get really nice and close to a skyscraper. You're looking at the top. Eventually, you won't be able to see the top of the skyscraper and all the subsequent floors below it. It starts to compress.
Right, but it doesn't disappear.
Yeah, you get close to a surface and the details are harder to see. Uh-huh.
All right, can you see my screen?
Yeah, so it's just the way your eyes work. It's the limits of your vision.
Can you see my screen?
Okay, limits to your vision doesn't cause obstruction.
Check out my screen. Oh, there's 10 people watching my screen. What the hell? Can you see that little white?
Okay, how high are you above the surface?
Oh, here's a quiz for you, Beasticles. Can you work it out from the image itself?
No.
I can. Okay, I can. And I do it by knowing that the Earth's a globe. Anyway,
Right.
at 23 meters. Yeah,
presupposition. Oh, I think I worked that out once.
You did. Jesse got it. Yeah. But can you see the little tippy top of the boat?
Okay, well, how high are you above the surface?
23 meters.
Okay.
Yeah. And these boats, these ships, they're like 30-something meters tall. Yet, the very tippy top of them appears well below horizontal.
Okay.
Does that accord with perspective? Given that the bases of the streetlights ramp up to eye level.
So in short distances, there's no refraction?
It's negligible at short distances.
What? How is that a short distance? How far away is that boat?
What? No.
How far away is that boat?
Streetlights.
Someone just said at short distances is refraction negligible. I'm like, yes.
How far away is that boat?
The boat is 35.7 Ks. I'll have to verify that, but
And there's no refraction affecting that.
didn't say that.
That's what you just said. You
Yeah,
said it's
nobody's-
negligible
No,
at short
someone
distances.
asked me if refraction is an effect at short distances. This
Yeah,
is
nobody
35
asked him if the
kilometers.
boat was a short distance. That was something other conclusion that you drew.
Okay.
Okay, the point I'm trying to get at here is how far away okay, it's negligible at what you say, like 45 kilometers?
No,
Nobody said that.
45 kilometers is heaps. I'm talking about looking down the street. Refraction's negligible.
Right, for streetlight observations.
Okay, so this observation you're pulling up right now is what we're talking about.
Yeah. Can you see the ship though? Can you see it?
Which one's the like that line horizontal? Is that the horizon where it should be?
Water. The water.
No. The where is the horizon in this specifically?
Where does it look like it is? The blue line.
Okay,
that
so where the
separates
water meets the sky. Okay, what's the
Yes.
crosshairs above it?
That's horizontal. So that's eye level, looking perfectly straight.
What height is this
23
image
meters.
taken at? 23 meters. He's seeing curve at 23 meters. Is that right?
Yeah.
That's what
This
he's
is
saying.
curve at 23 meters. Okay, cool, bro.
I
Yeah,
missed the.
And it also
missed the
it
joke.
looks like the water is angling off to the right.
It is,
Oh
yeah.
that's distortion
Dude.
in the lens, right? So you got to be close
This
to
whole,
the center.
this whole image is.
It
This,
seems it seems a little fishy.
this whole image is optical, bro. This whole entire
what's
thing
the
is optical.
what's the radius of the
This
Earth
is
based
what-
on this picture?
where's the hor-
What?
Right.
You ask where the
Of
horizon
course
is.
an
and
image
it's like,
is optical. What the fuck is that?
Yeah, this is a spherical lens, right? So it has barrel distortion towards the edges. That's why you see the curve left to right of the horizon. That's why I got the ship very close to the center, so there's no distortion.
Okay, so you're not acknowledging like any sort of curve here. It's just curving so much at this point. So all you're concerned about is the vertical collapse in this image. Then
Yeah,
you're
bottom
not
up
worried
refraction
about
and the
cool. Right, yeah.
dip to the horizon. Yeah, don't worry about left to right curve. That's a lens effect.
Sure.
But can you see the ship?
No.
How good is it? This
I
is
mean,
my
I
best
can.
capture ever.
Yeah, I can see a couple of pixels. Yeah, sure.
Yeah.
Oh, yeah.
Pretty cool. I'll show you what the ship looks like. It's called the Rostella.
Where did you take this?
Cliff up in DY, where I go before I go pick up my boy from school.
So this is Australia.
Yep. Sydney.
Yeah. And so you're just seeing the top of this ship. Is that what's going on?
Yep.
Yeah. You said you had a photo of the ship. Is that right?
Oh yeah. One sec.
So we're just looking at a couple of
MMSI images. That'll do. Boom. If I paste this,
I
in
just
here,
say
it's gonna fuck
the
it up.
bottom of the ship is just melting into the horizon at that point, man.
Hang
Like
on.
that's your bottom up obstruction basically occurring. It's all optical. There's a couple of pixels basically there that melt into the horizon. That's all
A
you've
couple
got.
of pixels.
How
This is
tall
what
is
we're
that ship?
seeing. This is how much we're seeing. This bit.
Okay, so how
All right,
tall
where's
is
the
that?
where's the curvature in this picture I just posted?
What's the distance of the ship again?
35.7, but I've got to verify that because marine traffic can be a bit wrong.
35 miles or kilometers?
Kilometers, yeah.
Oh, hold on. Where's the
35 kilometers.
Where's the curvature in the
Brilliant.
picture I just posted?
All right, is
It's
that
from
no
Blue
donks
Origin.
footage? Yeah, but is it no donks footage?
Yeah.
Okay. Do you know that he overcorrected it?
He overcorrected it. What does that mean?
Yes. Well, go and look at his footage on the ground, and you'll see that it's curved upwards.
Yeah. He wanted the horizon to be flat from altitude, and so he made it that way.
Correct. Got a lot of fluff.
So you do acknowledge that people can make things look a way that they want them to, right?
If they
Yes.
distort
Cool.
the images themselves, yes.
Right.
Yeah, so this ship, we're only seeing the top few meters of it, Did you want me to like verify the distance, Ricky?
Look, you said 37. I'm happy with that. I mean, it's already seeing too far as I'm concerned, at 23 meters above the surface. Sounds like you're already seeing too far. The image that you got, trying to look back for it, with a couple of pixels above it. I mean, you got black. You got a ship that's black at the bottom and white at the top, right?
Right. Yep.
I didn't see that distinction going on there. It just looks
Right,
white.
'cause the
It almost
whole
looks like
is
the black part.
The black part is below the horizon.
Do you have a series of images, Rufus, or just the two?
It's just melting into the horizon, bro.
I've got a video. This one, if you want a video.
You're getting a shimmer. Do you recognize it, like when the sky meets the horizon, like that sort of horizontal plane or whatever? Like,
I'll share the video.
There is a sort of mixing that occurs.
Yeah, it's called the marine layer.
Yeah, of that information, right?
There you go. Can you see it now?
I see.
You do realize that, like, once you remove this curvature thing, refraction isn't something that just doesn't exist, but that you can actually use refraction to obstruct things. Except on a flat Earth, that would be, some of it a cause in some cases, especially over water. I mean, if things just kind of disappear into mirage, then you're just looking at an aberration of the atmosphere. So,
I mean,
persistent observations of bottom-up obstruction on a flat Earth would require the air to be arranged upside down from what we measure it to be.
Yes. Doofus.
No, this is only if you're presuming the curvature is the physicality.
No, it's presuming
you're working on a refraction. No, you're working on a refraction model that is assuming the curve.
Incorrect.
Does not
refraction is based on what happens when light interacts with a medium.
Okay, then what is a mirage?
Mirage is when the light changes which direction it's normally going.
It's a type of refraction, is it not?
Yes.
I just said light changing direction. Do you want to say refraction is something other than that?
Can you zoom back in?
Okay, but if you're saying that light is going up and around, then you're presuming the surface, you're presuming the medium to be curving around that surface.
You're able to zoom in.
If it is a flat Earth, if it is a flat Earth,
incorrect. The reason why that's incorrect is because measuring the properties of air and then determining which direction the light will go through that air has nothing to do with the surface nearby that air.
Oh, there we are. Whoops.
Oh, boys.
When I discuss the properties of what light does through air, I'm talking about the air doing something to the light. It has nothing to do with the surface underneath of it.
Thanks, Gio, for hosting that event, bro. I'm going to bed. I'll see you later.
Zoom in, Ruhif, if you can. Continue on the conversation. I don't see the black part of the hull.
Right.
In fact, it seems to be actually be like at the bottom. It seems to be reflecting what's going on at the top. So it's extruding that white part of the ship.
You reckon there's an inferior mirage there? How about what we do? Let's do some geometry. Should we do that?
Yeah, man. Look at it.
Okay.
Well, it's all white. I mean, there's no black part of the ship, right?
Correct.
Exactly.
It's being, yeah, exactly. But it looks really, really high. And from the image that you showed me, it's way more extruded at that height point, which first it's actually a reflection going on.
All right, let's do some geometry. Now, first, we're gonna align the image so that it's vertical in the screen. So that 0.014, 0.014, second 10. So I've got to rotate it 0.8 degrees. My iPhone was rotated 0.8 degrees. And that should straighten up the thing. Oops, where we go.
Hey, Ruhif, with all due respect, and I'm not even trying to bring drama, even though it might sound like it a little bit. But dude, like, I haven't really seen the Globe Defense Team scramble quite as much as of late here with this whole thing of today. I'm really not trying to say it in like a you know, like, oh, you're scrambling, you're running. I'm not trying to say that. I'm saying like actual, like I can hear it in the tone of the voices, you know, like just because you guys really don't have an answer for it yet. It's pretty interesting.
We have his answer.
The times
from his location.
The times they are changing.
Right, from his location, his argument is inconsistent. But the globe, if we assume that his measurement with the theodolite is incorrect, and it measures 220, then everything matches the globe near perfectly.
All right.
Anyway,
Well, I mean, the thing is, though, is that just with that, if he took it from his home and he's not willing to give his like private information or whatever, that's obvious. So it's just sort of like, what that just means is that what he did, I guess, can't be replicated unless he gave his home information, which may not be the case. However, I mean, the thing is that this is also something that can be replicated. So I think it has just standing on its own in terms of that part of it, of replicating it.
No one's going to dox him. I mean, he has a master's in computer science.
That's his choice. It's his choice. Right. I mean, if he took a measurement from his home and he's not willing to give his information, then that means that his exact thing can't be exactly replicated. Therefore, his exact thing can't be replicated. However, this needs to be replicated in more scenarios, and it's the whole thing that's on the table now in terms of that level of, in terms of him presenting it and what it represents in terms of that being, you know. So,
but no one's going to dox him, and no one's going to force him to have a surveyor on his property, right? But you know, I took measures to obscure any identifying information. He thanked me for that. I Facebook messaged him, say, I'm about to make a video. You know, how much do you want me to obscure your location? Blah blah blah. Right? I'm not going to dox him. I'm not a threat to the guy, right? But like I said, if the measurement from a surveyor is way off from his, bendy space. I'm going to do the geometry very shortly. The measurement from a professional using an accurate instrument will match the globe. Both Jesse and I have done hundreds of these measurements. Anyway, let's do some geometry.
Are you still referring back to the theodolite measurement? It's not necessary if you've got your point, like your position and the height of the elevation of the peak.
Right, but then we get back to...
You don't need a theodolite. This is what's so brilliant about this entire observation, dude.
Yeah, if you throw out the theodolite measurement, then we go back to the point of, is stellarium accurate from some other location but not his house?
Theodolite's just your crux at this point. Like, you're having to rely on it.
Oh my God.
I mean, I don't know all the ins and outs of such an observation, dude, but if he's saying that it's not required, I mean, I don't understand. Like, what are you guys pointing forward? Do you think it's required to have a theodolite measurement?
How can I... Doofus, do you want to take this? Like, I don't know how many times we can say it. He threw away his theodolite measurement because he knows that if he accepts stellarium as correct, then his theodolite measurement was just plain wrong from his house. Yet,
yeah, but
he
like,
accepts
stellarium
from the mountain.
Yeah, I still haven't quite got my head around the notion of, like, when you say stellarium is correct, and then you can turn refraction on and off. Yep. What does that imply?
Right.
I mean,
so
is it correct with refraction, or is it correct without refraction? These are all just kind of odd terminologies.
So my position is that it's correct with refraction, and I can demonstrate that by taking angles at my house. If he says it's correct without refraction, that's fine. But he's
have you got a mountain?
No, I'm in Sydney. But
like,
if he
just
then
blue mountains all around you guys.
They're not very.
It's fine.
Yeah, it's not.
Find
easy.
a peak. Like, this is the thing. Like, at the end of the day, I think I mean, I don't want to cut this conversation in general short, but this is just a modality by which to make an observation, and you can use any peak corresponding with, you know, a respective star, and you can go do this stuff yourself. Any further conversation is kind of actually redundant. You need to disprove the method of the approach at that point, rather than using just like his experiment. You need to go do it yourselves.
Yeah, Ruhib, you got to drop it. Ruhib, drop 100,000 on a motorhome. Get the kids, pack them in. Get the wife, pack them all in the motorhome. Go on a little trip, go on a vacation up into the mountains, And while the kids are playing and they're swimming in the river, you're over there taking your measurements, looking at stars and mountains, and get a bunch of data.
There are two responses. Number one, if we do the calculations for a globe, both for the mountain with refraction and the star with refraction, it matches at 219. Right, that's what I predict a surveyor will measure. If you go with his celestial theodolite angles, he has thrown out his theodolite measurement and then taken as fact an angle in stellarium from the mountain, but rejected an angle from his house. So either stellarium is correct or incorrect, regardless of whether you have refraction on or off. Let's do some geometry. All right. Geometry. Now, with an auto level, Rick, the angular distance between these two stadia lines is 10 milliradians, right? That's by definition in the auto level, right? That's how they're made. All right, so we can work out, the angular size of the ship. All right, how long is the ship? It's called Ross Stella. Let's look up the ship and see how long it is. According to marine traffic, it is 110 meters long. All right, it's a 110 meters long ship. What is the angular width of that at 35.7 kilometers? Let's do the math on that one.
How do you know the orientation
maximum
of the
angular
ship?
width?
Because I've got video of it going right to left, and I also have marine traffic giving the speed and the course. It's heading 41 degrees, and it's almost exactly perpendicular to me.
Okay. See, I thought it was like heading straight down towards you, and you think that's even worse. You've got a vertical-looking image of pixels, and
just the pixels, bro.
Maybe just let him go through it instead of you interrupting, right?
Anyway, so
you think I'm interrupting
the angular size calculator.
I mean, the guy paused. I'm just making commentary on it.
That's fine.
Do I need to wait for him to?
All right, so I just plugged it into an angular size calculator. The width of the ship at 110 meters is 0.176 degrees. I'll stick that on there. Width equals 0.176 degrees. Black. There you go, that'll do. Oh, it's a terrible font. All right, 0.176. So the width, the angular width of the ship, like it's 110 meters long, but it's 36 k's away. So it has an angular size.
Great.
Yep.
Where's the dude? Just look at the image. I don't get what's going on here. You've got basically like two white patches. And actually, it seems to be a reflection, if you ask me. The bottom seems to be reflecting the top, or whichever way you want to refer to that. Where's the black part, dude? It's all just.
Where's the black part?
This is whatever this observation is. I don't feel like you've got anything concrete.
Okay. Well, do you understand why I laugh when you say "Where's the black part"?
Why I laugh too.
You think that entire thing is just the top hole? Oh my, geez, really?
Yes.
Okay,
Yes,
okay. Look at the proportions of the ship. You showed an image of it before. Okay, right?
I was about to get to that before you started talking.
Yeah.
Oh, sorry. Did I interrupt? Oh, my bad.
No, you're fine. You're fine. Keep going.
Continue on. Oh, I don't know. Doofus has got a problem, but whatever.
All right. So we're going to convert that angular width of the ship into units of milliradians, because that's what the stadia marks are in, right? 3 to milliradians. All right, 3.07 milliradians. All right, that's the width of the ship. All right, so from here, remember I said this is 10.
Did you post an image of the ship, Ruhif? I'm trying to look back.
Put it in the chat. One sec.
Cheers, man.
1 second. Rostella.
It's just like whatever that image is that you're looking at there. It seems it's a very tall, extruded bit of white stuff, essentially. And your ship had a black hull with a sort of a central point, which is all white. And this thing is just all white. It's a big, long, extruded little bit of white stuff. This is
have a look.
And
what
you're saying
the
that
top of the ship.
I don't see it, dude. I'm really.
Yeah, that's the point. You can't see the black part of the ship.
All right, so we got 3.07 milliradians. All right, so we said this is 10 between the top and the bottom is 10. All right, so 3 is, can you see my cursor like that? That's about 3, right?
I'm doing some video stuff. Like I'm going to show you some stuff in the background, but if anyone wants to jump in, go for it. But I'm just going to draw a couple of lines quickly.
That's 5. So 300, a little bit less than 300 pixels. So 300 pixels wide. $277. All right, that's about how long the ship is. Where's the how do I feel? There it is. Cool.
So I just uploaded an image.
Yep.
So you're saying that everything, like you got 2 red lines. The bottom line, everything's occluded behind what you've observed in that image. And then, right? So I'm just jumping between stuff here. And the only thing you can see is what's in between the 2 red lines, essentially.
No.
And it's this. Well, okay. So it's the white part of the ship. You can't see any of the black part right below. So you're saying everything in the middle of those 2 lines is what you're observing within those 2 little red arrows that you got?
No. I would move that second red line a lot higher.
Did you think the ship is that big at that distance?
I'm showing you how big it is at that distance. That's what we're doing. That's
interesting. Oh, I can see. Okay, so you're actually trying to use the claimed distance of the ship.
Yep.
And then you're doing something to work out what the width is, and then that's what the width is represented. Okay, gotcha.
Yes.
But that's clever. I'll give you that.
Yeah. So you can probably fill out the rest, right? We're going to do the same for the height. We can work out the height from a decent photo of the ship. Yeah. So sorry, they give you the length of the ship, but they never give you the height. So you've got to find a decent photo to take it from.
30. Is it about 30 kilometers or something? You said, yeah.
35.7 or something like that. Yeah, within a couple of kilometers. I would need to verify it because marine traffic has a bug. Let me grab that one, actually.
You need to get yourself an AIS receiver.
Yeah, I've got one, and I'm trying to write some stuff to automatically point the telescope or the mount towards the ship.
Oh, cool.
Yeah. I've written like full-on UDP protocol to my mount because they didn't have, the ASCOM standard. This mini mount doesn't have ASCOM. It's ridiculous.
I wrote a little Perl decoder that decodes the messages. You're welcome to it.
Nice. So the distance is to... Where's my little DY? Oops, shit. Where's my little DY spot? Down here. All right, the distance is... Oops, shit. Distance is 36.1 kilometers.
See, I just think everything's just being compressed at that point. You've got a little mast of the ship at the top because it sits slightly above the sort of range of compression, but everything at that point is just being compressed. into the horizon. And because it sits a little bit higher than the rest of the ship, you find yourself like at some point the information has to pop out of the horizon. And if you have a ship or an object at the limits of the horizon, yeah, the top of it is just going to pop out. It's going to look like it's disconnected from its foundation, essentially. And this is the nature of the optical illusion that we're having to deal with at the horizon.
When you say
where you guys are basically, yeah.
When you say compression, do you mean the sort of perspective effect of railroad sleepers appearing closer together the further away they are, or are you referring to a refraction effect of compression? Or both, or whatever.
I guess it's compressing. I don't know. Terminology is failing me here. Like I could say the vertical, or like it's compressing along the horizontal plane into the vertical. I don't know. The terminology is failing me as far as the specificity of how to actually articulate what's being suggested here. But
I'll stick something in chat. I
don't know. Can you imagine what I'm suggesting here, though? That like if you have a visual plane that is being compressed at its extent, that as you bring, if you had a tall object, right, at a distance, and is having to be resolved, you've got all this other kind of weird shit occurring between. I mean, this is an optical observation across the top of water, which is, I mean, it's actually counter to the way that you, Ruhif, generally sort of try to approach these long distance optical observations, right? Well, yeah, you keep talking about trying to get up to the top of mountains.
Yeah, like I said, this is in your interest to get above the surface because you guys don't have a good explanation for bottom-up obstruction. You can't model it. If I see a ship obstructed, I'm like, yay, Earth curve.
How do you think, right? Like, within the understanding of your like how optics work and all the rest of it, right? How do you think a tall object at a distance would come into, you know, how would you say, like an arranged artifact from getting off into the weeds? How would you imagine as you brought that like object forward, like a very tall object, like a ship, like really tall, as it comes into the site? What do you imagine? Like it's appearing from the top.
Globe?
Well, I mean, yeah, within your paradigm, so globe.
Yeah.
We'll mention it. Yeah. Okay, so suppose try to imagine the point is a flat Earth. How would you expect it to appear on a flat Earth?
Yeah, no bottom-up obstruction, equally scaling, like it gets bigger in all dimensions as it gets closer. There's no obstruction.
So there's no, like, I still think that the horizon sort of at that real fine sort of level, it's still melting into the horizon, the top, like where those two meet, there's an unresolvability that's occurring. And then as it comes into observation, it's actually like the image starts appearing from top to bottom because of that convergence factor that's occurring between the two horizons. So it occurs on a flat Earth as well, right? Do you understand where I'm coming from?
See the thing I posted at 24 minutes past, the railroad sleepers. Or you can imagine a chessboard. If you get down low to a chessboard, you can make out, you can resolve the squares in front of you, but the squares at the other side of the board are difficult to resolve. Is that what you mean by compression?
Yeah.
Yes. Okay.
It resolves itself from the top down because of the way that I'm using very sort of my own terminology of the way I've incorporated it, right? It's like I got no technical analysis on this, but the image that you showed as far as perspective is concerned, it's a vector. It doesn't take into account any sort of aberrations that are occurring at the event horizon of our horizon, right?
I think the follow-on point from the railroad tracks is to say that we're looking at a ship which is not flat or sort of you're not looking at that grazing angle like the railroad tracks, the checkerboard, or the ocean. We're looking at something that is perpendicular to our line of sight. It doesn't suffer from that perspective compression. It's vertical. Do you remember Jaron put the piece of paper on the floor of his garage and then put the camera on the floor and the piece of paper disappeared?
I'm not familiar with it, no.
Okay, well, that's what he did. He put the piece of paper on the floor, flat on the floor, put his camera on the ground, and like the piece of paper got really thin. But you know what didn't change is the garage door, because it's vertical. Right? It doesn't have that perspective compression effect. We're not looking at a grazing angle. We're looking pretty much perpendicular to it.
There's still something, in my opinion, going on at the horizon where the pixels are just melting. Like the information gets a bit jarbled, and it makes perfect sense to me that as something of a tall object moves into that field, that it will appear to it will appear from top down.
If you can model
because
it,
your angle of observation at the top is slightly higher than that at the horizon, right? So because it's such a tall object, it will actually because your angle of observation of that tall object, it will start crystallizing compared to that at the bottom of the object, right? Just imagine a flat Earth for a sec. Get rid of any sort of reality interpretation you've got. Just try to think of optics on a flat plane.
Yep.
Would you expect the top to appear before the bottom, given the fact that you acknowledge there's a convergence at the horizon?
Yeah, both whatever's below horizontal and above horizontal converge at the same rate. There's no bias to perspective.
No, but you have a higher angle of observation of the top of the object. It's a larger angle of observation than that which is at the horizon, and you acknowledge that the horizon sort of at those distances, what is it, less than half a degree or whatever at the horizon. Like all that stuff is just melting in between the two sort of planes of observation.
Yeah.
I don't understand where you're coming from.
Well, if you could model it and make a prediction using, just what's his name, Dave? New Perspective.
I just posted.
Yeah, but he posted some explanation, right? And I see that it's from Life is Short, Travis, blah blah blah. I've seen it. No one has used it to make a prediction for something like Canagoo, or if you think it's explainable.
I'm just trying to get away from that stuff for a second. I'm just trying to work out as an object comes into the field of view. It's my kind of the way I imagine it would work. It actually would appear from the top to the bottom because you've got a better angle of observation of the top of the object.
Okay, if you can model that, that would be great. I'm going to go make some dinner because I am hungry.
It's not modeling it, dude. You just
well, show me how it's predicted. Show it. The Life is Short presentation talks all about Rayleigh's criterion, perspective, blah, blah. But then I engaged him on Skype. This is 2018, 2019. And I explained Rayleigh's criterion to him. And he acknowledged, yes, Rayleigh's criterion cannot explain this observation. He was a reasonable person. Yeah, if you can model it and show a prediction, we've got things like Deutschler that can give you renders of what it should like on a flat Earth. Actually, we can give you, what's his name? Science It Out wrote a ray tracer. I wrote a shitty ray tracer. We can all make models for what we think it should look like on a flat Earth and a globe. We don't get that from the other side. Anyway, I'm hungry. I'll be off. Back soon.
In any case, I don't know. This is pretty cool though. As far as Heffening's presentation here, I kind of actually, when I first came into this, like, there's got to be a whole bunch of other opportunities as far as Heffening's null hypothesis to present as far as these observations. I don't quite know what they are. I don't know where to actually go looking for them specifically, but I think we can actually pull out a whole bunch of observations that basically deny and like follow logical conclusions to why there's a problem here to be observed as far as the globe is concerned. Apparently it took 10 years to come up with a celestial theodolite. You just need someone with original thinking to come into the community, because everyone just sort of gets bogged down with the standardized arguments. I'm a little bit surprised that the likes of Jesse never actually considered to use the peak of a mountain.
Well, the difficulty is I would have to appeal to the accuracy of stellarium to use that method. So that's why it was never a big thing, because if I says, look, I measured the moment this star clipped behind this mountain, and here's the angle that stellarium says it's at, you would say, well...
Totally granted, man.
What's that?
I grant you that. I think we all, as sort of, it seems to be the human complex or the human condition to get sort of bogged down in what we already know. We sort of, we sit into certain like sort of intuitive patterns of recognition that sort of, it's very problematic actually to find novel ways of looking at a problem, essentially. And I only point you out, my man, is because, I mean, you're the Theodolite fella and you do a lot of observations. It's not like I'm not also privy to the same problems. You know, whenever I see a problem, I always try to solve it in the way that I did before. And if I can't work out what the problem is, then I'll presume that the problem is potentially unsolvable. It's just sort of a fact of the human condition. Like, you see that with maturation of people, particularly older people. Like, they can't work out computers because it requires a novel or alternative way of thinking.
Yeah, and so I always tried to use the simplest, most primitive, most understandable method. And that's why I even used water tube levels, because, you know, there's a lot of people that don't understand the guts of stellarium, and they might not trust it. But a theodolite is a pretty simple tool. It physically measures the angle of the light ray as it enters the telescope. But some people don't understand that, so I even use the water tube level. So that's why I try to keep it simple.
Well, I mean, just Heffening's sort of proposition here, like, I mean, it's even simpler. You don't even need a theodolite, right? You can just use your position on the Earth, the provided height of the summit of the peak, and you don't need a theodolite to measure that, right? I mean, maybe you would like it in order to sort of proof a couple of conditions. I don't know. I just find it so fascinating that a fellow just came in like apparently a month ago. Obviously, he has a lot of like worked on knowledge throughout his sort of time and tenure as a like working within his occupation. So, you know, that's to be said. But I don't know, man. What is it? flat Earth argument's been going on for something pretty intensely for about a decade, and this seems to be rather a simple one. Like as far as like an experiment that can be done, it solves a lot of problems as far as refraction are concerned. Apparently, there's a whole gold, like that potentially reveals to me that there is a whole gold mine of different ways of like observing this that like are yet to be thought about. It's sort of, rather than just going and looking like down in the south, like Antarctica, looking for a 24-hour sun, right?
It's still not a valid method though, because it's untestable. You can't, it's like.
You mean it's unreplicatable or it's untestable?
Well, it's like this: if you take stellarium and pick a star and turn off atmosphere, and then point your telescope where it says to point it, you won't see that star. It will not give you the correct angle to point your telescope to if you turn stellarium or turn atmosphere off.
Okay.
So how do we know that that's really where the star is? He's saying you turn atmosphere off and it will tell you where that star truly is. But I point my telescope there and it's not there. So how do I know that the star is really there?
Brother.
When I point my telescope at that exact position and the
Can you steel man his argument? Or are you just going to continue to misrepresent? Just very weird.
Well, what do you think, Riggs? Don't you think that it would be good to be able to test?
Did you answer my question? I'm not. Actually, you know what? If I'm going to come back and talk to you at all, I am not going to avoid you are not going to avoid the question I ask and just go straight into something else entirely. This is your tactic. If you're going to misrepresent his thing, can you steelman it?
Like, you interrupted my conversation with someone else to ask me to steelman something. That's just bug off, by all means.
You first.
Damn, Jesse, that's the first time I've heard him say a cuss word, man.
Is bug off?
Did he say bug off?
I thought I said fuck off. I thought I said fuck off.
No, bug is in B-U-G. As in grasshopper, ladybug.
You're bugging me. Bug off.
Yeah.
I mean, the whole premise of his case was that you can actually match up. You can't actually match up the star. So it appears that they've layered the conclusion within different ideas of refraction. So that's basically his finding. So you're saying that that's not the case, that it can't be done, but that's literally what he's been documenting and continues to document.
No, he's saying stellarium is wrong for his own location, and it's correct for a different location that he's not at.
Yeah, that's just.
Isn't he showing that the line continues?
No. Without atmosphere, it actually creates a straight line at a different location.
Right, where he's not at.
There's atmosphere up there.
So then, have you got a problem with where he's at as far as stellarium is concerned? Like, he's not there, so you got a problem with stellarium at that point?
The angle prediction you get for a different location will not match your current location. It's not possible.
It's including. Oh my gosh.
You know that when you move across the surface of the Earth, the celestial sphere changes orientation relative to your position. However, for this argument to work, you have to say that that does not happen.
That's a very good point. That was my confusion.
You have to say 60 nautical miles per degree is not something that happens in reality in order for this argument to work.
So what do you make of this then, Doofus? Do you think this is just like a curious anomaly, or it's garbage data? Like, what's your position overall?
Some of it is garbage. So the angle to the star from a different location means nothing to someone who's in a different spot. It's pointless.
But if the star gets occluded, then what does that matter?
Yeah, it's
You have to
creating a
tell me why
syzygy.
the angle that he got to a star for a different place matters to him.
It creates a syzygy, a lineup of the 3 points from the observer, the mountain, and then the star. It's a syzygy.
In order to make that argument, in order to say that it creates a syzygy, you have to say that 60 nautical miles per degree does not happen in reality. You have to say that.
So then maybe it doesn't happen. I'm
We
not
know
sure.
that it does.
How do you know that?
Because when you change position on Earth, your position, the celestial sphere changes orientation relative to you. We know that happens.
That's cute.
Okay? All celestial navigation uses that fact.
What? They're using celestial navigation of stars at like right on the horizon, like a couple of degrees up from the horizon. I'm pretty sure
Is
that
that what I said,
celestial
or did you change it
navigation.
to something else?
Celestial navigation sort of orientates itself around sort of stars closer to the zenith, doesn't it?
Celestial navigation is applicable to any star anywhere. You can use corrections for stars that are close to the horizon, but that's not what I said. What I said was
corrections.
that the celestial sphere changes orientation relative to you when you move across the surface of the Earth. In order to make the argument that it creates a syzygy, then you have to say that that thing that I just said we observe in reality, we have to say it doesn't happen.
Is it augmented at the horizon more than it is at the zenith?
It's got nothing to do with the fucking horizon, man.
The zenith measurements is more accurate, no?
Jesus Christ, dude. The entire celestial sphere changes orientation relative to you when you move across the surface of the Earth. Do you agree or not agree?
Sure, agreed.
Okay. In order to make the argument that a straight line from the star to the mountaintop can be extended from there back to an observer in a different location, you have to also say that the celestial sphere does not change orientation relative to you as you move across the surface of the Earth. Do you understand the problem?
I do, yeah.
That's a good way of explaining it.
Well, at least I acknowledge your argument, right?
That was brought up like 4 or 5 times at least in the presentation, and for some reason it didn't click with anybody in the presentation.
Well, they have a more advanced knowledge of what's going on here exactly than what I do, so yeah.
Do they?
I would just like to know why the sky is the only place where perspective does not apply.
Nobody makes that claim.
The globe very specifically does.
Does not.
No.
No, yeah, so the globe, you're seeing your position to like Polaris because of your position on a globe, not because of your perspective.
No, it is your perspective. If you take the arctangent of the height of Polaris above your eye level line and the distance divided by the distance, that's the angle. That's the perspective angle.
Right, if we assume... Yeah.
Yeah, this is interesting. That this is like real basic stuff. That even Ruhif, is Ruhif still in here?
No, he had to eat.
Yeah, so yeah, Ruhif one time, a bunch of Globers were piling on me about it. They were like, they said the same thing you just did, and I said, hey, Ruhif, and he had to come in and correct them. And now you guys are trying to fucking gaslight me too. You see how bullshit this is?
Right, you seem to be having a problem with this. This isn't really a problem for the globe side. It's a problem that you're having right now.
No, because everywhere else in reality you apply perspective, but then it comes to the sky and you throw it out the window. I want to know what that scientific reason is for throwing out.
Well, you're mismaking that assertion, throwing it out the window. Has that been your experience when you made the measurements? No, because perspective, by my definition, is the tangent, sine, and cosine function. You don't even use those for anything ever.
Yeah, this is a lot more simple than that kind of stuff. This is your angle to Polaris is because you're not underneath the star anymore and it's to your side. Your position is that the globe has turned away, and so your position on that globe gives you your angle. You see the difference? Real simple stuff.
All right. I mentioned this earlier during the presentation. You might have missed it. But if you make a prediction for what direction you need to look in order to see something, there is no way you can leave out perspective. In order to make a prediction, to find out which direction you need to look, there's no way to end up with an answer that leaves out perspective. It's not possible.
All right, I guess that's all I need to hear. There's a conflict between you and other globers as to how you're interpreting the sky. That's all I have for now, I guess. There is. Go ask Ruhif. Ask Ruhif if he changed his position on that yet.
I've talked to him, in DMs. It's fine. The way that I'm using the word perspective in this case involves which way your orientation is involved in your perspective.
Yeah. I'm not as technically versed as you guys, and so this kind of stuff is more in my wheelhouse, I guess I might say. But no, I appreciate your answers. Thank you.
Okay.
Well, I've heard a lot of these, debates and arguments and points of contention, seen to their conclusion many times, so I just, I refrain from engaging any further than I feel is, I don't know. I just don't want to beat the dead horse, I guess.
Have you ever been on a 10-hour airplane flight?
Oh, no, not that long, no.
Sure. What happens on a 10-hour airplane flight?
Do you have any doubt that the distance to the destination is very well known?
Yeah, when it's over water, I do, but not over land.
Very well known. Okay, is your speed known at that point specifically? Or is it a GP sort of value that's...
Yeah, like, from flying from San Francisco to Hawaii. You think there's any doubt of the length of Great Circle route to get there?
It's the speed. I would put it contention. Your speed seems to be potentially assumed.
You think there's any doubt that they're not using, or that they're using any doubt that they're using GPS satellite navigation?
Well, I just referred to a GP, so yeah, there is no doubt. No, they're definitely using a GP location. I gave you that already.
I said GPS satellite navigation.
Well, I just said GP, global positioning. That's the proposition. There is no issue with the in my mind anyway, that the positions are correct upon the globe. It's if you want to talk about airplane flight, it's primarily to do with how fast that actual vehicle is going over the top of the surface. And if you're only going to use the GP coordinates as provided by, the industry that sort of suggests it, I mean, it's self-referential at that point. So
the industry that suggests it?
Yeah.
Latitude and longitude is not by industry.
Well,
industry suggests a Great Circle route to all the precision of the width of the wingspan of the airplane.
Don't know what you're talking about.
The precision of navigation by satellite.
Yeah.
Welcome to the globe.
Yeah, good luck, bro. I mean, I haven't even come to. I kind of engage in these what I sort of at a larger scope sort of refer to as an empirical data analysis. By no means by which I actually got to the globe, or got to an alternative version of the globe. I'm a purely sociological man, so this stuff is just for me to dance around with. You got a whole bunch of problems going on with the lies and contentions within the society itself, convincing it that it's doing